and Tanvi Patil. We are the students of MTech Geotechnical Engineering from COEP Technological University. We will be your host for this event, and we welcome you all to this grand event of Mahafest 2023, where we are celebrating 75 glorious years of Indian Geotechnical Society. Today, we are here with the theme of tunneling and underground constructions, organized by Indian Geotechnical Society, Maharashtra State, at this grand venue of MIT World Peace University. I would now request everyone to stand up for the MIT Peace Prayer.
आद्या वेद प्रतिपाद्या संवेद्या आत्मरूपा एवा तूति गणे अर्थमपि प्रकाशो आसु अवधारि बोधि ब्रह्मा गुरो महेश्वरः साक्षात् परब्रह्मा श्री गुरु पूर्णमिदं पूर्णमादाय पूर्णमेष्यते शान्ति शान्ति
Let's start our today's technical session. Our first speaker for the day is Dr. Ashish Juneja sir. Dr. Juneja sir is a professor at IIT Bombay. He completed his masters from IIT Delhi and his PhD from NUS Singapore. He's been working with IIT Bombay for past 18 years, and his research interests are in soil dynamics, underground structures, and ground improvement works. He's nominated member of TC 104, Physical Modeling in Geotechnics, and TC 204, Underground Construction. He twice received the Excellency in Teaching Award and the IIT Bombay Industrial Impact Award. Today, he is here to present his work on tunneling and ground improvement, lab and field investigation. Let's welcome him with a round of applause.
Thank you. Good morning again. We were to start at about 10. It's nearly 10:20 plus. So I request you to reset your watch to 10. Okay? We'll take about 50 minutes or so. If all goes well, we won't try to exceed our time. Sorry. So the idea is to have something. Okay, I need to look there or there. Okay, I'll look there. So the idea is to have share some of the experience which we have done as an experimental thing. I thought of, the number of subtopics when you deal with tunnels. Because tunnel is not a simple answer when you deal with different geological conditions. So if you're doing tunneling in soft, you get a different kind of answer. Tunneling in rock, hard rock, weathered rock, you get a different kind of answer. So my whole subject of today's talk is soft ground tunneling, which is rather more simplistic in terms of because the entire deformation which you see or you expect to see is visually you can really see in soft ground rather than anything which goes in hard ground. So there are certain things, aspects I'll speak. Mostly my talk is going to be on, one second. Okay. Okay, how do I change the slide, please? Okay, try again. Yes, sorry. So I tell you to change. Okay, no problem. Okay, so so do you mind if I stand here because I can't see anything what is there, right? So there are certain things we understand when we speak about tunneling. They are normally called horizontal structures, which are mainly historically have been used for transportation or in terms of travel transportation or in terms of connecting different areas. We have had a major tunneling infrastructure in this country for last, close to a decade, wherein we have used it for roadworks. We have expanded in terms of water supply. Recently, there have been projects on hydropower, enhancement of the existing hydropower utilities, and MRT is very much new, where we have massive underground corridors coming up. This is a challenge because you're not only tunneling in different geological conditions, but when you speak about urban areas, you're also doing construction which is close to either an existing structure, an existing pile foundation, an existing basement, or a basement or pile foundation which is going to come in future. In both the scenarios, I believe the answer is going to be different. In many Western countries, what we see is the tunnel or the underground structure has been there for decades, and the excavation and the pile comes in later. In our situation, it's rather different. We already have the deep foundations, existing deep foundations or existing basements, and now the tunnel comes in. So you can look at the kind of deformation scenario or the change in stress scenario, which in both the cases. So I would say the existing literature is helpful, but it cannot really be used directly unless we try to understand the differences. We have also looked at the method of construction. So can I just request for next slide, please? Yeah. So the method of construction can be cut and cover. That's the most simplest of all in case you have soft ground condition or your tunnel is close to the ground surface. You just cut, cover, and forget about it. Drill and blast would be one which is used for hard rock. You have soft ground TBMs and earth pressure balance machines, which are again soft ground. There's also a new thing coming up, which is double O tube tunnel, wherein you have two TBMs run by the same machinery and they go parallel to each other. Obviously, they would be used for very soft ground. And I think in the world, there are just 3 such locations where double O tube tunnels have been used. A slurry machine is there. Slurry is more commonly used because you can get different kind of ground conditions it can tackle over. So most of the TBMs which we see in this country, we kind of use slurry TBMs because you don't, you try to visualize because the slurry itself tries to balance the pressure in front. You have the TBM going in, something has to pressure the counterbalance the pressure at the front. We usually would not like people to go there because if it's a pressure balance, then the high pressure would not be so much of safety. It will create safety hazards. Then of course NATM, nothing new about it. We still call it New Austrian tunneling method. It's mainly used for I would say hard ground, wherein the presence of precast lining is avoided. So you spray or you use shotcrete the thing to cause, avoid the use of precast lining. Next slide, please. So we did a lot of centrifuge tests in this. So we've had few master students. I'm grateful to them because it's their work I'm presenting and some of the work which even PhD students had initiated. So the idea is, why do you need a centrifuge? Okay, so centrifuge, just to let you know, IIT Bombay has the largest centrifuge in South and Southeast Asia. So it's big, massive. It's like a big beam. I'll just show you some photographs wherein, we call it as a small bomb. Okay? Why do you need a centrifuge, first of all? It's people who are familiar with soil mechanics. I believe there are many students sitting at the back. Just to let you know, the students who are sitting at the back, my questions directly start from the back. Okay, so this is more like an interactive. So this is the right time for you to change your seat and move forward. Okay, and questions are not easy. Okay, so let's look at a simple case scenario. The figure on your right shows a simple plot. I guess you would be knowing a plot in consolidation, odometer. Vertical axis is a void ratio. Horizontal axis, instead of vertical stress, this time it's mean stress. So you have two soil samples. One is A and B. One is sitting on the right side of the failure line, and the other one is on the left side of the failure line. This failure line is a critical state line, conventional. If both the samples are sheared, let's presume they're sheared, either drained or undrained, doesn't matter. But once they're sheared, in this case I've shown a drained test, but the same scenario would also be for undrained. Sample A or soil A or conditions at A will make the soil move down, and the conditions at B will make the soil move up. I hope this concept is clear, because B is considered to be over-consolidated and A is considered to be normally consolidated. And if you look at the figure, that tries to explain the same thing. Sample A has a straight line, it asymptotes, and B has a hump. So this will give you a clear idea that both the samples have the same initial condition before you apply the load, before you start any construction over it. But the response is different. Response depends upon what is the value of P prime, in this case, which is the mean effective stress. It's easy to then understand that my response of the soil depends on what are the confining stresses. This is, again, a challenge because you can't generate confining stresses in a small bucket. Usually we have, when we do small lab experiment on pile foundation, we just push a rod in a bucket and try to shake it. That will not generate the enough P prime in this figure, as we see in the figure. You need the correct P prime or the stress value. So that is why at the bottom, if you can read, we know that soil is highly nonlinear. If it was a linear, it was just a straight line passing stress strain curve passing through zero and straight line. There won't be any fun in it. That's why in soil mechanics is the funniest, or I shouldn't use funniest, is the most interesting engineering aspect of all civil engineering. There are some experts in concrete technology. I usually make this statement, so apologize to them before I begin. What's the fun in having a stress strain curve which is so straight? All the equations are very set. So if I'm doing concrete technology, if I'm doing any structural engineering, I just have no fun. Soil starts from nonlinear right from the beginning. This is what makes this very interesting. So that's nonlinear. It's plastic. It has both elastic and plastic behavior. And because of this slide, I try to show that this is also stress dependent. It's because of the stress dependency, stress dependency that we use a centrifuge. Just to give you an idea what this whole thing is, on the left-hand side is this small, a rectangular chunk of soil wherein you see the mass M and dimensions L, B, and H. So if it's one gravity, that means you're sitting in the lab floor with this large chunk of earth. I mean, let's assume it's a huge, big, large chunk. Your sigma V, which is vertical pressure on the top, is the mass mg times lb, right? Straight 10 standard physics equation. Let's look at the right-hand side figure. You have high gravity in case I can make this g n times g, huge number. Okay, this number we will speak in the next slide. Now let's look at the thing. My mass is reduced by, each dimension is reduced by a factor of n. If I do that, please look at this carefully. My mass is reduced by n cubed, and each and every dimension is reduced by n. The end result is everything gets cancelled out. I'm running it at ng. All n's get cancelled out. What you see is the prototype stress level is the same stress level which you see in the, in the what do you call it, in the model scale. That means you can generate on the centrifuge the same stress state by running this whole thing on n times the gravity. So if you just look at another few, I have two more examples case. This is not limited, but just to again, because the simple physics, I think you and I, both, all of us understand. Let's look at the next one. Force is mass into acceleration. So simple, I think 10th or 11th we studied that. Let's look at in full scale, mass acceleration. Mass is now reduced by n cubed. The same, it comes from the previous slide. Acceleration is increased by n. One n gets cancelled out. So you have force, which is in model scale, is a function, I mean, compared to prototype, I have divided by n square. What does it mean? It means if I have true force in the ground on the centrifuge, I just need that force divided by n square value to generate the same response. I've taken an example of 50-ton pile. 50-ton pile is now conventional. 10, 15 years back, it used to be considered as a normal pile. But now we have super piles, which are nearly 200 ton, huge capacity here. You can't possibly do a field test if you want to do this. You have to, for 50-ton example, 50-ton capacity pile, if I want to do this on a centrifuge, I just need to apply 20 kilograms when n is 50. So if I run this centrifuge at 50 times gravity, this whole thing becomes, I need to apply 20 kilograms. That means I just make the most lightest person in this room, I think that'll still be 40, yeah? So I need to cut that maybe half. Even that weight is good enough. If you just put 1 foot on it, the lightest person in this room, I think that should still be able to generate enough load that is equal to response as 50 ton. That's the beauty. Consolidation is something we all understand, and it's again, look at TV equal to CVT upon h square. All students, undergraduate students, or even postgraduate would know this. TV is again time factor. Let's say time factor at full scale and small scale, I need the same time. CV is soil property, so I have T upon h square as a function. If I equate them using the same analogy as previous slide, what you see is the model time is 1 n square times the real time. Again, to give you perspective of scale value. So if I have 10 meter thick of clay, which takes 10 years to reach 95% consolidation, I can do the same thing in 1.5 days using the centrifuge. Okay? There are other relationships which you can, these are standard. So you can, in fact, follow them if you're interested. This is, again, an example. What you see is, just to let you know, if I rotate the merry-go-round, it's a simple merry-go-round. If I go to merry-go-round, the sketch on the right-hand side shows you that if merry-go-round rotates at an angular velocity omega, so r omega square equals to ng, fairly standard. This is your centrifugal force, right? R omega square equals to ng. Again, it's a school physics thing. You will find that every child on the merry-go-round wants to sit on the outermost horse. There's a reason, because sitting on the outermost horse, you get a kick. R is maximum from the center to the outermost. Look at the right side equation. R maximum, I get the maximum n value, which acts as a centrifugal force. So the resultant of ng and 1g, which acts down, the kick is given because your horse tilts by a huge quantity. I mean, so what quantity? They don't want to make it a huge quantity, otherwise every child will, every parent standing outside will have a heart attack. They just give enough tilt, which makes the child be happy. Okay? So take an example of 2 meter radius, which is going at 10 RPM. Omega of 10 RPM is 1 radian per second, taking G value of approximately 10. So I get an n of 0.2. With n is a fraction in this case. Okay? Next slide, please. Incidentally, that child on the photograph was my daughter, taken about, I think, more than 12 years back. Now she doesn't pose or model for me anymore. Okay, this is an example of an RPI centrifuge. It's a huge one. Huh? It's 150 G ton. 150 G ton means I can put 1 ton load on the bucket and rotate it at 150 to create 150 N. 150 times the gravity. Look at the number. Huh? To give you a perspective, you know, every fighter pilot in this country is made to sit on a centrifuge. Are you aware? If you are a fighter pilot, you have to exist up to, there's a magic number, 9G. If the fighter pilot survives 9G without, you know, fainting or puking or anything, he's given a thumbs up, and he's given a flyby, he can fly fighter plane. This is 9G here, and we're speaking about 150G. So if we consider this to a small bomb, anything goes wrong in the design, in the calculations, if the students submit tests, anything goes wrong, it'll be headlines in next day's newspaper. Just see, it's going to fly off and, you know, and create a huge thing. There are other centrifuges, please, next please. So this is a NUS centrifuge. It's a small one, 40 G ton compared to RPI. Again, 2-meter radius, and it's a maximum payload of only 400 kilograms. So if you put 400 kilograms, 40 G ton is equal to, so you can see how much of N is generated, because 40 G ton is a multiplier of 400 times N. That's, again, a city university, which is also a small one, of only 1.8 meter radius. Next, please. This is a large one. It's the biggest one. University of California of 9.1 meter radius, 400 G ton. Okay, they're very proud of it. And that's the Cambridge University, 150 G ton, 4.1 meter radius. Incidentally, NUS is coming out with a bigger centrifuge. And if that comes up, in next couple of years, we won't be number one. We'll probably go down. Okay, next, please. This is an IIT Bombay centrifuge. It's 4.5 meter radius. Okay, it's one of the fantastic machines. We have a model area is a package area. You know, the bucket which you spoke about, you need to put the bucket over it and rotate. So the kick you get on rotation is when the bucket moves from downward direction to nearly horizontal direction. Okay? So these are, again, there were different parts of the equipment available. To give you a perspective, the right-hand side is somewhere data points show horizontal axis is up to what G level it can go and what is the payload capacity. What you see is somewhere over there, where the black dot is, that's IIT Bombay. And you see, you know, we are really towards one of the larger centrifuges in the world itself. Why I brought this centrifuge topic was the bottom figure. This is taken from ground engineering way back 1999. It gives all the, you know, what do you call it, geotechnical engineering, the important topics move from left to right. If you look at it, for the foremost research papers come out in critical state, and somewhere centrifuge is still number 5 out of the top 8. This is, again, the reason that why we consider centrifuge is still considered as one of the, you know, what do you call it, forerunners in terms of research. Give you again how centrifuge has come up in terms of geotechnology. One of the pioneer works was Edward Phillips. Way back 1969, he was a physicist, by the way. He came out with this, you know, simple experiments to, you know, simulate sulfate stresses. Until I think about 60 plus years, nothing happened. Then Philip Buckley, he started mining problems using a centrifuge. Same time, in fact, Soviet scientists, you can you know, use your own judgment how to pronounce these two names, but it's Pokosvy and Davinskov, I think, regards to them. They did a lot of research. In fact, if you have studied historically, Soviet Union never been open. It's been always secretive. And this is the reason people outside the world never knew what was happening. And they did a lot of excellent works in terms of mining engineering, huge work. It was only when Andrew Scottfield had a chance to visit them, when one of the Soviet scientists had presented this paper in external forum, when Scottfield, as people call him as ANS, he kind of got an idea how centrifuge can be used for this. And he went back to his Cambridge. He built a smaller centrifuge over there, And later on with this two students, Roscoe and two more students. So Roscoe Roscoe is the teacher, ANS is student, apologies. Ken Roscoe was the teacher, so Roscoe came out with a larger centrifuge to build up, which is the Cambridge centrifuge as of now. And ANS and along with others, they built up this large centrifuge over there. Of course, ANS is still there. He's still very much alive and kicking. Thereafter, a number of centrifuges started to come up. There was huge amount of work done in the European Union in terms of the usage of centrifuge. And Japanese are world leaders. To give you an idea, every project, civil engineering project, every project is tested on a centrifuge, and then it's done really. If it passes the centrifuge, then it goes taken to the real scale. That means you build it real. In IIT Bombay, Professor V.S. Chandrasekhar, he started this. I think he built this one excellent facility over there. Okay. So my first one over here is how you model the tunnel excavation on the centrifuge. That's the first one. So the cross section of a TBM is something like this. I think I borrowed it from some online literature, but that's the photograph of a model TBM which is used for Mumbai Metro. You have a cutting wheel with a shield, and all the muck which is collected behind is carried on by RKBD screw way back, and then it falls on a conveyor belt, and you see those lorries down there. Those lorries are your small wagons, and wagons are then pulled back to the entrance of the tunnel where they're carried up. Okay, that's a general background. TBM on the top, I'll move from top left to bottom. So top left shows a first section of the TBM. Whole TBM is about 50 meter plus, and it's into 3 sections. So each section is lowered, entered, and then jacked in. Then second section lowered, jacked in, and third one. Okay. By now, that's the first section, and this is the Terminal 2, Terminal 2 airport at Bombay. So it's lowered down, pushed in, and then the second photograph, it's already there, and you see those jacks. Okay, those jacks, same jacks which are used for driving when your liner, segments of the liner are there, the jacks push the liner back, they take reaction of it from there. And then the lorries are there, they carry the muck outside. Bottom left figure, the lorries are outside, and then they are lifted up using cranes and then dumped outside the site. Okay, that's the sequence of field, how a TBM moves. Okay, the progress is pretty slow. It's about hardly a few meters per day. So that's why even doing a tunnel of 1.5 kilometers, you see that in newspaper it comes out that TBM went in about 1.5 years back. Now it's coming out half a kilometer later. It's coming out from the other end. It's a slow progress. Okay. Now, why we study this? Why does it make this whole subject interesting as a civil engineer or a geotechnical engineer who are experts in this room? Okay. No, sorry, can I just look at it? Yeah. So you see this, there is surface settlement, because if settlement is large, we call it subsidence. So subsidence happens at the perimeter. So this whole thing is vertical cross-sections. If I look at its cross-section this way, look at the bottom figure, which will be easier to understand. The same deformation at the surface is like a, what do you call it? What do you call this settlement, this figure, smart people? Normal distribution? Yeah, normal distribution. So that's a normal distribution or Gaussian distribution, you can call it. So that's a settlement curve which happens when TBM moves forward. Reason is obvious, the mouth of the TBM is larger than the tail. That's one of the reasons. The mouth creates a larger hole and the tail narrows down. Okay, it's easy to cut, but the people who construct are so experts now that the volume loss in this is kept bare minimum. We look at those numbers later. And the other kind of deformation is the front one, deformation in front from the face. And most of the geological problems happen from the front face. Are you aware there's a TBM stuck in Himalayas because of, again, the front face has made it difficult to remove. It's stuck over there. And wonder how much each TBM costs. I think, throw in numbers. 27 crores? 40, 70? That's a second or third hand TBM. Okay? Usually it's 100 plus. Huh? And many TBMs are recycled. That's again, because we can't afford to spend so much again. Okay? So one of the largest TBM which will be coming in this country is 13.1 meter diameter. It's the largest TBM. The usual TBM we have is about 6.2, 6.3 meter diameter. Okay? So the settlement in the front is a major problem as well. So we're looking at cross-sectional settlement, which is again, because depending upon the level of quality of the contractor as well as this from the front face here, because you enter into unknown. Okay? So we looked at both things, and the cross-section is, as you heard, is normal distribution, Gaussian distribution. And in Gaussian distribution, ignore the equation. I'll try to keep the equations minimum in this. Look at this. There is an I at the denominator. That I is the point where the curvature changes different. There's a change in curvature. Okay. And if you look at the figures, that's block white color. That's the point I, distance I. How much is I? And everybody on this planet is working on to or measure or calculate or estimate what is this I value. And many of us have been doing this. Next, please. And settlements have been there. Failures have occurred. It's not that tunnels don't fail. Left one is Nicole Highway at Singapore, and then Sydney, Beijing, and of course, but reasons were different. I won't say it's because of the TBM moving in alone. There are failures, but reasons are there. Next, please. So the first one was deformation in unsupported and I'll speak about two topics, unsupported and supported tunnel in soft ground. And the second topic is when you're tunneling near existing pile foundation. So that's the container, large container. We call it strong box. You put sand. In fact, the model tunnel has been prepared using latex rubber. Yeah, this is a very old technology we borrowed. I do not know if you're aware. How many of you know what is triaxial test? Simple triaxial. Have you seen in your life? Show of hands. There is an air-water interface. You know, how much does that rubber cost? Any idea? Because, maybe this is a very rich place. You don't worry about small change. But it costs about 10,000 or so, 8 to 10,000 for each rubber balloon. Okay? So we try to make this at our home. This is something which is, again, we tried something, and in fact, one master student here made a lot of good quality, with some kind of additional nano thing he added, and did a master's here. So this is, again, we use one technology to make rubber balloons for the rubber tubes for the tunnel liner. And the same material is used for your triaxial air-water interface. This was an example. And we had some standpipes and different things, but I'll just move on to next, please, just to show you. So, the photograph shows those markers. Initially, now, of course, the technology has gone very fast. So we used, the hair color dye. You throw in the dye powder on the sand or on the clay, and you take pictures, and the change in texture tells you how the soil has deformed. Technology has moved. PIV, as we call it. We stole it from the water resource people. Okay, that was an easy thing. And this is something. Prior to this, I would say we still use it sometimes, but we use spaghetti over here. Noodles, spaghetti noodles, they're crisp, hard, so when you put them, they're easy to lay. So all these white lines are, in fact, your spaghetti. They turn white later. We tried with spaghetti earlier, and there was something wrong. Next day, overnight, the rats in the lab used to dig it out and eat away the spaghetti. So we used to find every time we have an experiment set up ready, it takes entire 1 week, and then rats come and eat away the spaghetti. So of course, we used heavy lids so that rats don't enter and things like that. These spaghetti we use as markers, and we use camera to take pictures while this whole thing is running. You visualize this is running, no one can go in to take picture, so everything is taken online, system, and the data is collected through slip rings. Slip rings, incidentally, is something, you have a wire at the bottom of it. You can't have a wire go through centrifuge, otherwise the wire will curl out and break off. So you have a slip ring, bottom of the slip ring, you have the wire going in, there are brushes, and there's a slip ring at the top. Both rotate, and they have connection. They transmit the data, you could say wirelessly, but it's something like, the brushes are actually in contact all the time. So that's the, oops, thoda sa rewind. That's, never mind. This is, if you see here, blink, I think he has switched on the video. Bottom is snapshot taken, which shows the ground deformation, the spaghetti going down as the tunnel deforms. Okay? So I think it was, you can barely, I think, make out. If you blink, you will miss it, huh? Yeah, so we digitized these markers, we digitized, and this was, again, for each and every test, we had these variables, C, Z0, and relative density. We changed all that. And can we just move on to next, please? This is the deformation profile. So this is at prototype scale, not model scale. So I purposely made it so that just to excite you, because model scale will be hardly few millimeters. If you see few millimeters, geotechnical engineers are not excited. When they see numbers in hundreds of millimeter ground deformation, unka heart stops breathing, beating, because this is 800 millimeter settlement. When tunnel is at about 3.75 meters, then we have tunnels at about 5.75. And you see at different regions, you have these from using spaghetti markers and digitizing, we saw that, how this profile looks like. And if you see, this profile is quite similar to your normal distribution, Gaussian distribution, as we discussed this earlier. Next, please. So we got all this data. The blue line, the blue dot points is data from our own smart research students. A horizontal axis is I, the same I, which comes from the previous one, normalized by R. And the vertical axis is your Z0. I think that's the depth of tunnel, normalized by the diameter. So that range, if you can see, there's a range over there. I think I can use a marker. Okay. So there's a narrow range. Meyer is considered to be topmost person. Meyer's work in tunnel, soft ground tunneling. Meyer's data lies within these two range. He says I is so much Z, so that's a range given by Meyer. And the PEC has given a slightly larger range above groundwater and below groundwater. Our data seems to lie right bang within the the range which should happen. And as a teacher, when you see such kind of data, first thing you do is call up the student and say, data fudge to nahi kiya na? Did you do any engineering to the data to make sure to bring it to within that? So but this is a good quality data because of good quality testing done. What you see is, again, data which is present in I by Z0 minus Z, and Z is the cover, I guess, and Z by Z0. Okay? And again, Meyer et al.'s data is black line. Our data is quite close to it. Okay? That's the settlement profile, and you see those potentiometers at the top which have taken the settlement along the top. So this is after the test, please. Next. The second thing which we saw, again, if you're using left-hand side is a dense sand, same tunnel in dense sand, right-hand side is loose sand. Do you see any difference? Ignore the write-up, that's rubbish. Just look at the figures. Do you see any difference? Point O. You see the point O? Point O in dense sand is at the bottom of the tunnel, and in dense sand it is bottom of the tunnel. Loose sand, it is below the tunnel. So that's where the entire zone of disturbance is confined by radiating lines which are coming from point O. That's one difference. The other one, in loose sand, the width of the trough is narrow, and in dense sand it is slightly wider. Okay. Next, please. There's something called, we call it as minimum support pressure required to maintain stable tunnel during tunneling. There's a concept. So when you have an opening in this kind of shape, an arch shape, you would have read the arching effect creates some additional stability. The Romans, they have built arched bridge. All the arched bridge, you apply any load, it goes to the two ends. It's because of the arching effect. Same thing, the arching effect is a self-stabilizing kind of a tool even in tunneling. And this is, when you reduce the pressure of the tunnel, the rubber, rubber membrane, reduce. Now it is from 1, it means it is balancing the overburden. And now, from balancing the overburden to about 60 or 40% of the overburden, then bang, your tunnel, in fact, collapses. It just goes in. You see a sudden collapse of the tunnel. So what you see is your tunnel support of about 50%, 50 to 60% is, if the support reduces by half, tunnel is still momentarily stable, or is a temporary phase where tunnel can be stable. This test is done in sand. What about silt and clay? Arching effects are really more prominent. You can really see that. So what you see is over here, bottom line, 0.4 times the overburden, or 50 to 60% of the overburden is minimum required to support the tunnel. Okay? That next was existing pile foundation. In fact, to give you a perspective, we thought of doing tunneling in, when you have ground improvement works and you have those micro piles. We thought of that kind of thing. That was one way of understanding. But this was ground improvement micro is one effect. Each and every pile is not connected. But over here, there's another perspective. On all the piles, maybe some piles are connected to each other, by a beam or something like that. So there is historically some work which tries to explain all this. Let me skip all this because what it essence tries to show or say is that there is an effect. And this, just let me take you back a few slides back when we said there is a pile and now you tunnel. And in second case, there's a tunnel and then you pile. In both the cases, the stress in the pile are going to change, okay? And your tunnel and your stresses in the liner are also going to be affected. I think this is one major cause of concern for many urban, where tunneling in urban areas happen. Can you next? So there's a difference. The tunnel-pile interaction is not the same as tunnel and reinforcement interaction. As I said first, although the relative stiffness is similar, but the piles are usually restrained at the top, which increases the stiffness or flexural rigidity, and therefore the deformations don't occur very much. Okay, and because the soil deforms, piles don't deform, you have negative scrim friction coming up on the pile. The vertical reinforcement, on the other hand, are free-floating columns. They're freely allowed to settle down or move down. Okay? And reinforcement, of course, are not designed to carry any load. So that's, again, a set of experiment we had. Just the results. I think the right side figure is the result. There are two set of curves, very similar. You remember the normal distribution we started with? So this normal distribution has been split into two. The left-hand side you see is the one where you have piles next to tunnel. The right-hand side is the green field. So there's a green field and I shouldn't call it brown field, but green field and not so green field on the left-hand side. What you see is, of course, you see that distribution similar, the normal kind of distribution, but there is difference. The maximum deformation you will see because of the presence of pile is reduced. Okay? If you go to the next one, I'll just give you another effect. The green field was that formula, the same thing as normal distribution. The slightly adjusted formula, please don't look at the formula as a whole. Look at the numbers. 2 has reduced to 1.4, and the 1/2 has increased to decreased to 1/2.85. So that, in fact, makes this curve much sharper. It actually kills the curvature on its own. Okay? Next, please. So we have put in data over here, the greenfield data as well as with the pile data. This time the pile is colored with yellow. So what you see is, yes, the data skews towards the left-hand side. The greenfield I was around 0.31 or 0.33 times Z0. Z0 is again the depth of the tunnel. And on the data with piles has skewed towards the left, more towards the, I would say, the extreme end of Meyer and Taylor's work. Taylor, in fact, is the R.N. Taylor, our print, what do you call it? Taylor. Neil Taylor. So, and yeah, coming on, so I think, so the results, what do you call it? I do not know where I was. Yeah, somewhere there. So the results are still within the boundary, I would say, but of course, more towards the left-hand side. Okay, next, please. We looked at the left-hand side figure. If you see here, this is interesting. Remember the top figure, we said the ultimate failure where the whole thing collapses, arch fails. Remember, arch is about half, 50% of the overburden. So remember, I excavate the ground and the pressure inside are reduced by half, then only the tunnel moves in. If you look at the bottom figure with pile, both the results are quite similar. It means you have pile foundation, the ultimate failure will not change. Okay, so your tunnel if the presence of pile will not delay the onset of failure. Okay, but it will affect the deformation prior to failure. This is the takeaway from today's presentation. Huh? This is not the end. Few more slides. Huh? Don't run away. So. Yeah, this is again a summary. I like to skip because otherwise the next speaker is going to crib if I take more point. I'm still going to take 10 more minutes because I started late. Who's the next speaker, please? I'm sorry, madam. It's them to blame, huh? This person sitting here. Okay, so I'll still skip this because this is just something, I think, putting it in English, what I have just said. If you're keen, you can just steal from the slides from the organizers. Next, please. This is interesting because remember the phase stability which we spoke about, failure occurring from the front. So this one technology which I'm not sure if you heard, this is called as umbrella arch. Okay, so in umbrella arch, what you do is you, on the face of the tunnel, top tunnel, you poke in some rods. Okay. You poke in rods so that it creates an umbrella on top of the ground, and then you excavate below. So it creates like a cover effect, an arching effect over it. And this is typically has been used, Mumbai Metro, they have used a scissors crossing. This is famous scissors crossing near Sahar Airport. And incidentally, where two tunnels crisscross each other, timing has to be perfect, you can't have two tunnels going to, so the trains crisscross each other, so they had to widen this opening. Usually they were going through using TBM, and TBM in hard rock is child's work. They don't have to worry. Only thing is watering is an issue, dewatering, major problem. But in this case, they had to create an umbrella arch because they had to widen it. So I'm sure you can't see it because the rods are in darker side, no lights over there. The lights coming out from some trailer and some kind of buggies which were there, but you can't see that. But the thing is, right side figure gives you a nice sketch how the umbrella arch is. Okay, so the idea is to have some kind of support. Next, please. So. Again, there's a background to it. Settlement ahead of tunnel in saturated sand, it said can reduce with the use of 4 poles or umbrella arch. Maximum settlement, this again some background literature, and I like to, it just says that maximum settlement occurs within 1 diameter head. I think this is boring stuff. Can you please move on? So this is what we have used. And next, please, I think. Yeah, so look at the bottom figure. The first master student, this is his work, okay? He's now a faculty at NIT. He was in Patna earlier, but so IIT Patna, but now he's moved to Dharwad. Nice work, huh? So this is, again, where you see a half section of the tunnel, bottom left figure. There is a steel section. I'm sure you can see this maybe. There's a steel section which shows the part of the tunnel which already has, the liners. And ahead of the liner, you see those created by the rods. Okay? And then it's spun up on the centrifuge. Next, please. Yes, so instruments, some pore pressure transducers, potentiometers were used. The important thing this time is water in the tunnel. In the previous test, we had tunnel and we had water, and then we removed the water to allow the tunnel to squeeze in. This time, the tunnel is of larger diameter. The tunnel diameter, I think, previous please, is 65 millimeters and running into 100 G. Give me a number, 65 times 100. So you're modeling a 6.5 meter diameter tunnel. And now the question comes in from two backbenchers. You have a 6.5 meter diameter tunnel. If I have water filled with it and I remove the water, will that be a proper model thing? It's a physics question. Backbenchers of niche dekh rahe hain. Usual, typical, our own IIT students, they look here, there as if, some what do you call it? Kab khatam karega ye? Something like that. They're just thinking the same thing. Huh? Okay, water, what is the density of water in CGS units? See, density of water kitna hai? Grams. CGS units, huh? 1. Typical 1 gram. So if I fill this with water and the earth pressure which balances the pressure of the soil, that's soil, this is 1. I can generate maximum unit weight of water 1 times the whatever is the height of water in the tunnel, right? So it cannot balance the tunnel because in a large diameter tunnel, 6 meter of earth, visualize this, the triangular stress increase with depth. I can't use 1. I have to use a value which is close to density of soil. That means around 2, 1.5 to 2, maybe less, maybe more. So you use zinc chloride and you change the concentration of zinc chloride to change the density of water. Density of the solution so that it balances the phase. So this is where this thing comes in handy. The settlement on the right side photograph was shown, the right-hand side photograph showed the settlement. This is where you see this. You have a rigid liner, that's a lining system, and without any left side figure is without any 4 poles, and right side 2 figures show the change in length of the 4 poles. If you have very sharp, quite sharp eyes, you would be able to see the contours change drastically. There is a change in the deformation ahead of the tunnel with the use of 4 poles. And usually, if you go to next slide, please. Usually, you come out with a stability number. This is, again, a second question coming up to the people, not from backbenchers because they are looking here and there, but people who are front of there, slightly front, who are daredevils, who try to venture, come towards the front. The left side figure is excess pore water pressure. You see these numbers, they are negative. Right? Negative. Negative, it's negative excess pore pressure. Can you just go back to the photograph? Photograph, please. No, yeah. You see the right-hand side bottom photograph? The tunnel has collapsed and the soil has moved towards the collapsed tunnel. Pore pressure transducers are somewhere inside that funny region, the collapsed region. They are giving us negative pore water pressure. It's normally consolidated clay. It should not show negative pore water pressure, right? In this case, why is it showing negative? Any bright person in this room? Students, of course. Faculty are not so bright like me. Right, students, come on, there's a price to it. Why would pore pressure be negative? It's collapsing, it's actually, can you go to the pore pressure response, please? Yeah, this one. The delta U is minus. You see here, the soil has moved into the cavity, it has dilated. This is dilation, right? You have soil and it has created what dilation. This is when it dilates, then only you get negative pore pressure. Of course, dilation is more like volume change, but the tendency to dilate or when the soil wants to dilate, but you don't allow that in undrained condition, this is negative, right? Same thing when the soil is normally consolidated in shear, it should not dilate, it should just create positive pore pressure, but in this case, the soil is allowed to move inside the cavity, so it has created a negative pore pressure. This was the thing, Can you go to next, please? Usually, when you use when you speak about stability of tunnel in soft soil, you look at a stability number. Don't look at that formula very carefully, but these are related to the depth and dimension of the tunnel and the overburden. Stability number, a number of maybe 10, 12, 22. These are numbers where it'll excite people like us. 22 is a good number. 10, 11 will make my heart skip faster. Okay, so that's stability number for a tunnel in soft ground. You look at it. This formula nowhere has the pole, 4 poles in the equation in the formula. So there's some modification done. We introduced stability number in terms of length and diameter of the 4 poles, L by D ratio. I think D is the diameter of the tunnel, not 4 poles. The length of the 4 pole normalized by the diameter of the tunnel. And with some modification, we came out with a slightly modified formula. Again, don't look at this formula so much in detail, which will confuse you, but in general, it shows that you can introduce the 4 poles in the stability number formula. Next, please. So to conclude, within an hour, madam. To conclude, pile foundations are shown to marginally restrict the soil flow and control settlement in tunnel deformation. The spacing to diameter ratio of the piles, they help to reduce volume loss. We didn't speak much about it, but volume loss normally when they speak about tunneling is, I do not know if somebody has spoken yesterday, but is how much the tunnel has converged to the original diameter of the tunnel and 1 unit length. That's why volume comes in. Otherwise, it's just area. So area, 1 unit length, volume loss. And just to throw in numbers, how much of volume loss usually you see in the field or throw in numbers, please. Any number. When you go out and buy something, say how much you want some pocket money, how much money you want. So you ask your parents for it, or you ask your friends for it. So throw in numbers for this. Volume loss. How much volume loss is usually permissible or usually occurs in the field? 5%, 1%, 0.5%, 20%, 100%. 100% with it will be like, those Titan, right? The Titanic, the submarine which went inside, unfortunately, with 5 people. What's it? Titan. It was called Titan, right? That was totally collapsed. That was the 100%, everything collapsed. That's 100%, talking about such large numbers. But typically, volume loss would be, any number would be helpful. Sorry? 10%? 10% में तो बहुत litigation cases आ जाएंगे. Like every person in this town will become billionaires overnight because litigation case इतने हो जाएंगे, you'll get a lot of money. Usually it's about 1%. And good contractor will restrict to 0.7, 0.5%. 1.5% is also seen. Okay? So these are the numbers which so there is a red marker, alert sign. They say that at 0.5%, there's some indicator marker. Whenever this exceeds 0.5, yellow light, a marker comes in and people are allowed to move with caution. When it increases to 1%, work is still slowed down but not stopped. Once it exceeds 1%, stop work. That's how they move. In the industry, how they move. Okay, next. The 4 poles. 2 line और थी यार बोलने दे. Four poles, they influence to reduce the length of settlement trough ahead of the tunnel face, but the width of the trough remains unaffected. The tunnel stability not only depends upon the unsupported length, but also on the length of the four poles. आप कर सकते हो. Okay, with this, I thank you for your patience. Thank you. I think this was taken on the way to Shridi. No, sorry, this is not the case, not that, because the Shridi doesn't have a gate. And the length, these are pretty long. This is somewhere else, sorry, not there. No, this was in fact outside. I think they won't answer. Any questions if you have? 1 minute. If not, thank you. Sorry. IIT Bombay Centrifuge, Professor VSC said it's one of the cheapest one they have made because they did all this, they didn't buy off the shelf. Okay, off the shelf would easily cost more than just the centrifuge itself, half the price, half the length, 2 meter, I can tell 2 meter length, something around 11 crores, just the centrifuge. Instrumentation will cost 11 more. Our centrifuge was built in, I think in less than, Murthy may know, 1.5 crores, everything. It's fabricated here. So I think a local company from somewhere from Bihar came in and they collaborated with local company to make it. There was no foreign thing coming up. Data logger came in later, but of course what I speak about is only the machine. Data loggers, wiring, everything will double the price. It just doubles the price. And now recently we have a data logger, and I think one more, and we found out if you write to Professor Vishwanathan, he is the coordinator over there. He is the king man over there. So you can write to him and know more. Thank you.
Excuse me, sir. You can stay here for some time. You can stay here for some time. Thank you so much, sir, for introducing us the centrifuge modeling and its importance in such a small time. Now I'd like to invite Dr. Uttam Kalaune, sir, to felicitate Dr. Ashish Juneja, sir. Thank you, sir. Moving forward to our second speaker of the day, Srimati Pranali Tamanskar ma'am. She is graduated from Sardar Patel College of Engineering, Mumbai, and post-graduated in Construction Management from SPPU. She served as a trainee engineer at Kalpataru Builders. Since 2008, she has been serving as a sub-engineer in MCGM in Mumbai Sewage Disposal Project Department. She has handled various projects in the department, but one of the most unique is India's smallest diameter segmental sewer tunnel project by earth pressure balance method, for which she was the project in charge. Let's welcome her with a big round of applause.
Yes. Hello, everyone. This is Pranali Dhamnaskar from sub engineer from BMC sub engineer since 15 years. So my topic is segmental tunneling. First of all, I want to thank IGS members for inviting me here and giving me such a prestigious platform to present myself. I'll start with my topic, segmental tunneling. Next. Next one. I'll start with the very basic topic. What is tunneling? Anyone? The answer is here only. See, the tunneling is nothing but excavated passageway which dug through surrounded soil or rock material. Okay, म्हणजे आपल्या मराठीमध्ये भुयार म्हणतो, that kind of a thing, which is opened from end and exit point. That is called a shaft. That's it. Okay, next. We'll see the history of tunneling. Some 4,000 years ago, Babylonian and Persian architects were the first who discovered the tunnel construction techniques. The first tunnel was built between two buildings connecting royal palace and a temple. That was about 910 meters long. The network of the tunnel is called, what's called pune or curries. That was lined up with the bricks that time because RCC structure was not there that time. Irrigation tunnels were also used to transport water underground through the deserts. In Iranian city of Gonabad, still have working network of Curries tunnels. That is 2007 years old network. Greek and Romans also got the knowledge, all the knowledge from the Babylonian and improved it. TBM were first launched in 20th century, connecting England and France, and that is completed in 1994. Now we'll see the history of tunnels in India. Next, Kena. Okay. आपण जर आपलं प्रीहिस्टॉरिक टाइम बघितला तर महाभारता टाइममध्ये पांडवांनी एस्केप टनल कन्स्ट्रक्ट केला होता. दॅट वॉज आवर फर्स्ट historic tunnel, I feel. Then many of the king constructed escape tunnel from their forts to safer place to be used during emergencies. आपले दैवत छत्रपती शिवाजी महाराज त्यांच्या गडकिल्ल्यांवरती असे बरेच सारे टनल होते ज्याच्यामधनं आपण एस्केप टनल त्यांनी बिल्ड केले होते तेव्हापासून. The first TBM in India introduced by BMC, that was a water tunnel. That was since 1982 to 1989 from Mahalakshmi Racecourse to Malabar Hill Reservoir. The first undersea TBM is also introduced by BMC itself in 1997. That was 2 outfalls and the same department that I am working, Worli and Bandra outfalls. The length of the tunnel was 3.4 and 3.7 kilometers under sea. Let's see the advantages and disadvantages of tunneling. First, we'll see the advantages of tunneling. No disturbance on a surface or a life or a ground activities or transportation. High speed construction, low power consumption, reduces noise pollution as all the activities are underground except the shaft portion. Freedom from snow and iceberg hazards in high altitude areas. Let's see the disadvantages of tunneling. First is cost and second is time. Regarding cost, initial cost is more, then requires a skilled labor and technical supervision. So it costs more. Then time, sometimes requires more time, depends upon the strata and underground utilities. Let's see the some methods of tunnel constructions. Cut and cover, tunnel boring machine, New Australian tunneling method, NATM that is. Then drilling and blasting, pipe pushing and jacking method, that is micro tunneling, which is using for less than 2-meter diameter. Then shell tunneling, then immersed tube method, that is used for undersea. As my topic is segment tunneling, we'll see the tunnel boring machine first. Classification of tunnel boring machines. Tunnel boring machines, that is rotating cutter head. They have two basic classification depending upon the strata, that is soft and a hard count. We'll see the segmental tunnel boring machine. It is having 3 types, slurry type, earth pressure, and mechanical excavation time. I have used earth pressure balance method in my project, and secondly, I am using this slurry type TBM in my second project. Next. We'll see segmental tunneling. So basically, what is tunneling? Okay. The segment is nothing but a lining of a tunnel. The lining may be wooden or RCC or a brick, but nowadays we are using just RCC tunneling. Segmental tunnel lining is an efficient way to create a stable tunnel following a tunnel boring machine. It gives a TBM or excavated soil a perfect stability to the tunnel. Let's see how the segments are going to cast. If you can see the first, this one, these are the segment molds. These are specially designed mixed alloy. It is manufactured from Taiwan at my place. Then after procurement of the molds, we do calibration of the molds, that is measurements. We used to do it with the vernier caliber. And after every 600 repetitions, we again calibrated it so that we can see there are any measurement deflects or anything. Then segment reinforcement. Next. ही जाळी आहे सेगमेंट्सची आणि याच्यामध्ये यूज करतो आपण CRS FE 500 corrosion resistant steel, then 500D and 550D. Then design was considered 20 km per meter square. Overburden आपण कन्सिडर करून ह्याचं डिझाइन केलं जातं आणि हे असे प्लेस केल्यानंतर then we'll do the concreting of the segment, that is casting. Next. If you can see RCC segments, here it is concreting is going on. M50 grade concreting we are using, that is a bucket head. And specially I wanted to say these segments molds are self-vibratory. That means you no need to take that vibratory machine to vibrate the concrete. It is self-vibratory. It is having one knob over here. आणि ते स्वतः व्हायब्रेट होतात आणि ऑल ओव्हर हे करतात, सेटल करतात कॉन्क्रीट आणि त्याची फिनिशिंग एवढी चांगली येते की त्याच्यामध्ये काहीच वॉइड्स नाही राहत. नेक्स्ट. हियर आय वॉन्टेड टू से व्हॉट इज सेगमेंट्स. सेगमेंट्स ऑल टुगेदर कॉल्ड अ रिंग. ओके, जरा बॅकची करना. If you can see, these are 1, 2, 3, 4, 5. 5 are segments and this is a key. Key is most important segment in the whole ring, which directs the tunnel direction. Next one. After casting of segments, we used to do a micro finishing applying curing compound to it. आता curing compound का एवढ्या ह्यूज प्रमाणात आपण सेगमेंट्स कास्ट करतो की त्याच्यामध्ये आपण हीट क्युरिंग केली जाते, पण त्याचा सेटअप एवढा महाग जातो की बेटर क्युरिंग कंपाऊंड हे ऑप्शन जास्त इकॉनॉमिकल आणि रिझल्ट वाईज इज ऑल्सो गुड. सो वी यूज क्युरिंग कंपाऊंड ओव्हर हियर. Then after building a segments, casting of segment, that is trial ring just, we put as consecutive segments each over above. 3 segments आपण एकावर एक बसवतो आणि त्याच्यामध्ये आपण ट्रायल रिंग चेकिंग केली जाते. तर ट्रायल रिंग चेकिंग म्हणजे काय की ॲक्च्युअल कास्टिंग ऑफ सेगमेंट करण्याच्या अगोदर आपण हे जे ट्रायल रिंग बनवतो त्या ट्रायल रिंगचे इंटरनल अँड एक्सटर्नल डायमीटर आपण चेक करतो, मेजरमेंट चेक करतो, प्लस 2 सेगमेंटच्या मधले जी गॅप असते ती ±5 mm or 3 mm असते, ती ॲज पर स्पेसिफिकेशन आहे की नाही हे चेक केलं जातं. अँड इफ इट गेट्स अप्रूव्ड फ्रॉम ऑल मग आपण ॲक्च्युअल कास्टिंग सुरू करतो. नेक्स्ट. सो फिक्सिंग ऑफ रबर गॅस्केट ऑन अ सेगमेंट. सी बेसिकली कसं आहे की हे गॅस्केट्स आहेत, स्पेशल रबर गॅस्केट्स असतात, हे साऊथ कोरियामधनं आपण प्रोक्युअर केलेले आहेत. ह्या सेगमेंट्सला इथे इथे ग्रूव केलेला असतो आणि त्या ग्रूवमध्ये हे हायली रबरचे गॅस्केट्स आपण स्टिक ऑन करतो, बिकॉज द सेगमेंटचं कॉन्क्रीट पोर्शन फेस टू फेस त्याला कनेक्ट नाही होत. जेव्हा सेगमेंट्स कनेक्ट केले जातात त्यांना रबर गॅस्केटवरती ते त्या फेसवरती कनेक्ट होतात, सो दॅट वॉटर टाईट बॉडी व्हायला आउटसाईडचं पाणी किंवा आउटसाईडचं ग्राउंड वॉटर आहे त्याचं सिपेज आतमध्ये टनलमध्ये येऊ नये, याच्याकरता हे गॅस्केट्स खूप इम्पॉर्टंट असतात. नेक्स्ट केस स्टडी. आता हे आपले सेगमेंट्स तर झाले रेडी. नाउ वी विल सी द केस स्टडी. व्हॉट इज इट? माझा प्रोजेक्ट होता इंडिया स्मॉलेस्ट डायमीटर सेगमेंटल सिवर टनल बाय अर्थ प्रेशर बॅलन्स मेथड. जुनेजा सरांनी ऑलरेडी अर्थ प्रेशर बॅलन्स मेथडचं बरेच डिटेल आपल्याला दिली आहे. मी फक्त एक्झिक्युशन पार्ट सांगते कारण की तो माझा फोटे नाही आहे. त्यांनी खूप टेक्निकल लेक्चर दिलेलं आहे खरं तर. नेम ऑफ द प्रोजेक्ट वॉज डिझाईन अँड कन्स्ट्रक्शन ऑफ सिवर टनल फ्रॉम जय भारत पंपिंग स्टेशन अँड टू बांद्रा IPS बाय सेगमेंटल tunneling method. Employer is obviously BMC. Then PMC was TC. Contractor was ITD Cementation India Limited. Length and diameter was 1.875 kilometers and 2.6 meter diameter. This is India's smallest diameter by earth pressure balance method, but it is a sewer tunnel. Number of shafts were 4. Shafts are nothing but a well type structure. ज्याच्यामध्ये आपण installation of टनल करतो, TBM मशीन आपण लॉन्चिंग करतो, देन ब्रेक थ्रू करतो किंवा इंटिमिजिएट शाफ्ट घेतो जिथे आपण वेगवेगळे C1 नेटवर्क्स कनेक्ट करतो. त्याच्याकरता आपल्याला वर्टिकल शाफ्ट्स घ्यावे लागतात. अदर दॅन दॅट आपण सगळं अंडरग्राऊंड करतो, वरची काहीच होत नाही. लेट्स सी द ऑब्जेक्टिव्ह ऑफ द प्रोजेक्ट. Improving the quality and reliability of wastewater collection, treatment and disposal. The SV Road Sewer Tunnel is intended to act as a deep collector sewer for all sewage flow of SV Road. कौन मुंबई से है? Anyone? Last benches. Okay, SV Road माहिती आहे कोणाला? SV Road माहिती आहे का? बांद्रा? No? माहिती आहे? अच्छा. मुंबई, ॲज यू ऑल नो की मुंबई ऑलरेडी हायली डेन्सली पॉप्युलेटेड आहे. तर तिथे SV रोडला ऑलरेडी एवढं ट्रॅफिकेटेड आहे आणि तिथे ड्युरिंग मान्सून पाणी खूप भरतं. तो जो पोर्शन आहे तो स्पेशली वेस्टर्न रेल्वे कॉलनी खार वेस्टचा पोर्शन जो आहे तो. आणि तिकडेच आमचं एक जय भारत पंपिंग स्टेशन म्हणून 1963चं कमेन्समेंट झालेलं एक पंपिंग स्टेशन आहे. एवढं जुनं आहे, 1963 अँड टुडे इज 2023. सो तो फ्लो घ्यायला ते पंपिंग स्टेशन कपेबल नाही आहे आता. सो वी नीड टू थिंक की ते काय करायचं, कारण की मॉन्सूनमध्ये काय व्हायचं, त्याचे जे पंप्स आहेत ते सगळे अंडरग्राऊंड आहेत. सो पावसामध्ये पाणी भरल्यानंतर ते डिस्कंटिन्यू होऊन जायचं. त्यामुळे मग सिवेजचा फ्लो पण पूर्ण रस्त्यावरती यायचा. इट बिकम्स मेस ओव्हर देअर. आणि हे बरेच वर्ष चालू आहे. माझा प्रोजेक्ट आता 22 डिसेंबर 2022ला कमेन्स झाला. त्याच्यानंतर यावर्षी तिथे जराही वॉटर लॉगिंग झालं नाही बिकॉज ऑफ दिस टनल. सो मेन क्रायटेरिया तो होता टू डिस्कंटिन्यू दॅट ओल्ड पंपिंग स्टेशन and cater all the flow which is coming extra to provide healthier and improved environment for the people of Mumbai, to decommission the Jai Bharat pumping station and Chimbai pumping station, as I said earlier, to relieve the flooding situation in front of Western Railway Colony along SP Road. Next. So we will see the tunnel alignment now. If you can see SV01, that is my shaft, first shaft, that is the sewage collecting point. All the collection of sewage is going from here, collecting shaft, and it is going through, आम्ही हा नंतर cancel केला due to some issues. Then it will go directly from here. Then here is mother and son statue. One shaft we have taken over here. And here one Chimbai pumping station connection is going to come. Atta झालं नाही आहे ते, but a future connection आहे ते. Then it will go to shaft number 3, which is under Bandra IPS, Bandra Influent Pumping Station. 26 जुलै प्रत्येकाला माहिती असेल मुंबईमध्ये काय झालं होतं, हवॉक सिच्युएशन. आणि तेव्हा हा बँड्रा IPS 2005लाच कमिशन झालं होतं. आणि हे कमिशन झालं होतं त्यामुळे जेवढी हवॉक झाली असती सिच्युएशन तेवढी झाली नाही बिकॉज ऑफ दिस पंपिंग स्टेशन ॲक्च्युली. सो आम्ही फ्लो सगळा जो कलेक्ट करतो आहे आणि तो पूर्ण बँड्रा IPSला येऊन आता तो बँड्रा IPSला नंतर ट्रीटमेंट होऊन पुढे जात आहे. लेट्स सी नेक्स्ट. Now we'll move ahead. Earth pressure balance tunnel boring machine. What is EPB tunnel boring machines? Are shield TBMs specially designed for operation in soft ground conditions containing water under pressure, loose sedimentary deposits, sandy gravel, silt, clay, formation with large boulders and high water table. So basically हा soft to medium strata साठी EPB यूज केला जातो. स्लरी TBM पण यूज केलं जातं, बट स्लरी TBM इज मच मोर कॉस्टलियर दॅन EPB. सो इट इज डिपेंडिंग अपॉन द प्रोजेक्ट टाईप किंवा तो प्रोजेक्ट केवढा मोठा आहे त्याच्यानुसार आपण डिसाईड करतो की EPB करायचं की स्लरी TBM करायचं. आता हा जो होता प्रोजेक्ट हा 2 किलोमीटरचा होता ऑलमोस्ट. माझा नेक्स्ट प्रोजेक्ट आहे तो 6.85 किलोमीटरचा आहे आणि नेक्स्ट प्रोजेक्ट आहे तो 4.8चा आहे. बट the PST1 project was 6.8 kilometer is having 3.2 diameter ID. So तो तेवढा फिजिबल होतो करायला आणि परवडतं कॉन्ट्रॅक्टरला डेफिनेटली. आणि मेनली हे EPBमध्ये प्रॉब्लेम असा होतो की जे मक निघतो तो मक जो निघतो तो कन्व्हेअर बेल्टने निघतो आणि कन्व्हेअर बेल्टमधनं निघत असताना तो मक डेफिनेटली त्या मक कार्टमध्ये घेताना पूर्ण ऑल ओव्हर टनलमध्ये पसरतो आणि मग तो क्लिनिंग ही जी प्रोसेस आहे ती खूप टिडियस होते. म्हणजे जेव्हा माझं कमिशन झालं त्याच्या एक 6 महिने अगोदरपर्यंत आम्ही तो मग क्लिनिंगच करत होतो. म्हणजे इट टूक 6 months टू क्लीन होल द टनल. म्हणजे 2 किलोमीटरचा टनल क्लीन करण्याकरता आम्हाला 6 महिने गेले. आणि प्लस स्मॉलेस्ट डायमीटर असल्यामुळे तिथे क्लिनिंगचा इश्यू होताच, प्लस अनहायजेनिक होतं कारण की तो मग सतत तिकडे राहतो. बेंटोनाईट त्याच्यामध्ये असतं, फोम असतो, which is not good for health. But we adopted because slurry TBM मध्ये एवढं 2.6चं डायमीटरचं मशीनच बनत नाही कारण की तो सेटअपच नाही बनत. सो वी टू अडॉप्ट दिस EPB मेथड. नेक्स्ट स्लाइड. सो हाऊ डू EPB TBM वर्क्स? सो बेसिकली दे यूज एक्सकवेटेड. EPB मीन्स अर्थ प्रेशर बॅलन्स. तर नावामध्येच त्याच्या मिनिंग लिहिलेलं आहे की अर्थ प्रेशर बॅलन्स. अर्थ मीन्स एक्सकवेटेड सॉईल. सो टनलच्या TBMच्या फेसला कटहेड असतात. तो फोटो आहे ना, हां, कटहेड्स असतात. ह्या कटहेडच्या सहाय्याने आपण कटिंग करत जातो पुढची अर्थ. आणि मग ते आतमध्ये एक्सकवेशन चेंबरमध्ये जी एक्सकवेटेड सॉईल आहे ती येते, आतमध्ये येते. आणि मग ती आल्यानंतर बल्क हेडच्या साहाय्याने ती मिक्स केली जाते फोम आणि फोम आणि बेंटोनाईटच्या साहाय्याने मिक्स करून त्याचं प्लिएबल म्हणजे फ्लोईंग मटेरियल असं बनवलं जातं. देन इट क्रिएट्स अ बल्क हेड. सो बेसिकली जेवढं प्रेशर सराउंडिंगला आहे, ग्राउंड वॉटरला आहे, ओके, ग्राउंड वॉटर आणि आजूबाजूचं जेवढं रॉक आहे, मास आहे, तेवढं प्रेशर आपण आपल्या एक्सकवेशन चेंबरमध्ये मेंटेन केलं की बॅलन्स मेंटेन झाला की मग ते कटर हेड पुढे पुढे जातं. दॅट इज अर्थ प्रेशर बॅलन्स. ओके, विल गो नेक्स्ट. पुढे जाऊ दे. The muck is then used to provide a support and a balance pressure at the tunnel face. This is the basic concept of EPB. Next. आपण आता जनरल प्रोसेस बघूया टनलिंगमध्ये कशी केली जाते. प्री टेंडरिंग प्रोसेस. सो सिलेक्टिंग टनल कन्स्ट्रक्शन टेक्निक्स. पहिल्यांदी द डायमीटर ॲज पर द रिक्वायरमेंट, टोपोग्राफी, जिओलॉजी अँड अवेबिलिटी ऑफ द लँड एक्सेट्रा. हे पहिल्यांदी आपण बिफोर टेंडरिंग आपण हे पहिल्यांदी कन्सल्टंट आणि यांच्याकडनं आपल्या रिक्वायरमेंटनुसार आपण डिझाईन करतो की आपल्याला कुठच्या प्रकारची म्हणजे सेगमेंटल करायचं आहे, त्याचा फ्लो किती आहे, की मायक्रो टनलमध्ये होणार आहे, ते आपण कन्सिडर करून बिफोर त्याचं प्रिपरेशन केलं जातं. देन प्रिपरेशन ऑफ डिझाईन अँड एस्टिमेट ॲज पर अवेलेबल डाटा अँड रिक्वायरमेंट, त्याच्यानुसार डिझाईन केलं जातं. देन टेंडरिंग अँड अवॉर्ड ऑफ कॉन्ट्रॅक्ट टू L1 बिडर. L1 बिडर मीन्स लोएस्ट बिडर. देन पोस्ट टेंडरिंग प्रोसेसेस म्हणजे टेंडर अवॉर्ड झाल्यानंतर प्रोसेस काय येणार तर टोपोग्राफी सर्वे डेफिनेटली, जिओ टेक्निकल इन्व्हेस्टिगेशन म्हणजे बोरहोल्स आहेत, एक्झिस्टिंग युटिलिटीज काय काय आहेत त्याचं आपल्याला पहिल्यांदा इन्व्हेस्टिगेशन करून घ्यावं लागतं बिफोर स्टार्टिंग कमेन्सिंग द वर्क. देन एक्सकवेशन अँड कन्स्ट्रक्शन ऑफ शाफ्ट. ॲज आय टोल्ड अर्लियर, शाफ्ट इज नथिंग बट वर्टिकल वेल टाईप स्ट्रक्चर. त्याच्यामध्ये जे आपल्याला लॉन्चिंग TBM आहे किंवा त्याच्यामध्ये आपल्याला ॲडिशनल कोणते नेटवर्क ॲड ऑन करायचं आहे तेव्हा आपण वर्टिकल शाफ्ट घेतो. अदरवाईज लॉन्चिंगसाठी आणि ब्रेक थ्रूसाठी 2 शाफ्ट कंपल्सरी लागतात. देन कन्स्ट्रक्शन ऑफ सेगमेंट्स ॲट कास्टिंग यार्ड, जे मी पहिल्या स्लाईड्समध्ये क्लिअर केलं. नेक्स्ट. देन लॉन्चिंग ऑफ TBM अँड लोअरिंग ऑफ बॅकअप गॅरंटी. लॉन्चिंग ऑफ TBM हा एक इम्पॉर्टंट माइलस्टोन आहे, कारण की TBM आल्यानंतर त्याचं डिस्मॅन्टलिंग केलेलं असतं जेव्हा तो येतो तेव्हा. त्याच्यानंतर त्याची असेंबलिंग केली जाते, पुन्हा 3 पार्टमध्ये येतो इन जनरल. त्याचं असेंबलिंग करून मग पुन्हा आपल्याला त्याचं लॉन्चिंग करावं लागतं, स्पेशल क्रेन मागवावी लागते. आणि मग ते लॉन्चिंग केल्यानंतर जी पहिल्यांदा 100 मीटर इनिशियल ड्राईव्ह केला जातो, त्याची प्रोसेस खूप स्लो असते कारण की ते कसं वर्क करतं आहे, काय स्टार्टा लागतो आहे, वी नीड टू स्टडी ऑन दॅट. तो 100 मीटरपर्यंत आपण खूप स्लो जातो. एकदा 100 मीटर्स गेल्यानंतर त्याची बॅकअप गॅन्ट्री ऑलमोस्ट 100 मीटर्सची असते. म्हणजे तो पूर्ण सेटअप आपण बाहेर ठेवलेला असतो. त्याच्यामध्ये त्याचं इलेक्ट्रिकल हे आहे, बेंटोनाईट आहे, मगचं आहे, ते सगळी गॅन्ट्री मागच्या साईडला आपण अटॅच करत जातो. जसं तो पुढे पुढे जातो तसं. देन इरेक्शन, प्लेसिंग अँड ग्राउटिंग ऑफ सेगमेंट्स. सॉरी. इरेक्शन, प्लेसिंग अँड ग्राउटिंग ऑफ सेगमेंट्स हे आपण मी फोटोमध्ये दाखवते नंतर पुढच्या स्लाईड्समध्ये. देन मग रिमूव्हल हा सगळ्यात मोठा EPBमध्ये TDS जॉब आहे खरं तर. रिट्रायवल ऑफ TBM, ब्रेक थ्रू और डे लाईट सेरेमनी. दिस इज व्हेरी मच इम्पॉर्टंट फॉर अस, फॉर टनल इंजिनियर, बिकॉज एकदा लॉन्चिंग झाल्यानंतर ब्रेक थ्रू होण्यासाठी आम्ही जीवाचा आटापिटा करतो की ते एकदा कधी ब्रेक थ्रू होतं. मध्येच कुठे अडकलं, काय झालं की जीव खालीवरती होत असतो लिटरली. म्हणजे मी माझा एक किस्सा सांगेन की आमचं टनल लॉन्च झालं आणि पहिल्याच 100 मीटरला आम्ही स्लमच्या खालून गेलो, पण ते स्लमला त्याचा त्रस जाणवला पण नाही पूर्ण 100 मीटर जाईपर्यंत. बट ते वर्टिकल एक्सकवेशन आम्ही शाफ्टचं करत असताना त्यांना प्रचंड त्रास झाला आणि प्रचंड प्रॉब्लेम आले आम्हाला. बट एकदा ती TBM लॉन्च झाली आणि ॲक्च्युअल म्हणजे ती 15 मीटर डाऊन होती TBM, पण त्यांना थ्रस्ट वरती जराही जाणवलं नाही. ती ब्रेक थ्रू म्हणजे ब्रेक थ्रू होईपर्यंत त्यांना जाणवलं नाही. बट मिठी रिवर, ॲज यू नो ऑल, मिठी रिवर क्रॉस करताना, नाला क्रॉस करताना नाल्यामध्ये रॉक लागला, ठीक आहे, पण नाला क्रॉस केल्यानंतर तिथे काही पुढच्या ठिकाणी त्यांनी मे बी भरणी केली होती. तिकडे एवढं प्रचंड सीपेज आम्हाला आलं की लिटरली आम्ही 8 दिवस 10 दिवस आमचे असे फोनाफोनी चालले की कोणीही मुंबईच्या बाहेर जायचं नाही आहे, कोणीही ऑफिस सोडून जायचं नाही आहे आणि कोणीही रात्री फोन पण बंद ठेवायचं नाही आहे. वी वेअर ऑन द टो की काय होणार आहे, कारण की एवढं सीपेज येत होतं आणि मशीन पुढे जात नव्हती. जेव्हा एका एका दिवसाला आमच्या 8 मीटर वगैरे रिंग्स जातात, त्या 1 मीटर 2 मीटर पण जात नव्हत्या, एमने सरकत होती आणि सॉईल एवढी कोलॅप्स होत होती की आम्ही बेंटोनाईट एक्स्ट्रा बेंटोनाईट मारून मारून ती स्टेबल करण्याचा प्रयत्न करत होतो. बट आम्ही थ्रू झालो. तो पोर्शनच फक्त तेवढा होता, अदरवाईज पुढे सगळं क्लिअर आलं. सो आपण अंडरग्राऊंडचं वी कॅनॉट प्रेडिक्ट की भले आपण सॉईल इन्व्हेस्टिगेशन केलं आहे, बट वी कॅनॉट म्हणजे ते सॉईल इन्व्हेस्टिगेशन आपण 10 मीटर 10 मीटरला करतो, पण मध्ये काही फिशर आलं किंवा मध्ये असे कुठची भरणीवाली लँड आली तर वी कॅनॉट प्रेडिक्ट दॅट. नेक्स्ट मग रिट्रायवल ऑफ TBM, देन बेंचिंग ॲट द शाफ्ट बॉटम. मी हे फोटोजमध्ये दाखवेन. फिनिशिंग ऑफ द शाफ्ट विथ द PU कोटिंग. एक केमिकल कोटिंग देतो आपण, जे शाफ्टचं कॉन्क्रीट आहे त्याच्यामध्ये काही रिॲक्शन होऊ नये म्हणून, बिकॉज माझं सीवर टनल आहे. तो सीवरचं म्हणजे मिथेन गॅस आणि डेंजरस गॅसेस इट विल क्रिएट आफ्टर कमिशनिंग. देर प्रोविजनल ऑफ व्हेंट पाईप ॲट ईच शाफ्ट. इट इज व्हेरी इम्पॉर्टंट, कारण की आज कमिशनिंग झाल्यानंतर आम्हाला फेस करावे लागत आहेत काही इश्यूज की व्हेंट पाईप कमी झाल्यामुळे किंवा कमी ठिकाणी दिल्यामुळे ड्यू टू सम इश्यूज, ज्या काही ठिकाणी 2-2 शाफ्ट देता आले नाहीत आम्हाला, कारण जो आमचा लॉन्चिंग शाफ्ट जो रिसिविंग शाफ्ट आहे जिथून मी सिवर फ्लो कलेक्ट करते तो रोडवरती आहे आणि तो रोडवरती असल्यामुळे आम्हाला एकच वेंट शाफ्ट देता आला आहे आणि तिथे थोडे इश्यूज क्रिएट झाले. वी आर सर्चिंग फॉर बेटर सोल्युशन ऑन इट. देन इन्स्टॉलेशन ऑफ SS स्क्रीन अँड मंकी लॅडर. डेफिनेटली स्क्रीन तर लावावी लागणार आहे, कारण की आपला सिवर फ्लो म्हणजे सिवर फ्लोज घेऊन जात नाही, त्याच्यासोबत स्ट्रॉम वॉटर ड्रेनचं पण बरंच काही प्रकरण येतं सोबत, त्याच्याबरोबर गाद्या, प्लास्टिक, बॉल सगळं येतं. सो वी नीड दॅट, कारण की टनलमध्ये ते जायच्या अगोदर स्क्रीनिंग करणं खूप इम्पॉर्टंट आहे. कनेक्टिंग एक्झिस्टिंग नेटवर्क ॲट द शाफ्ट लोकेशन, देन लेईंग टॉप और कवर स्लॅब ऑन इच शाफ्ट अँड लास्टली कमिशनिंग. So we'll see the major hurdles faced. Next one. आमच्या साईडवरती आमचे 2 का 3 शाफ्ट मेन रोडवरती होते. तर मेन रोडवरती काम करणं म्हणजे ट्रॅफिकचा इशू आणि अनऑफिशियल बोलायला गेली तर कॉम्प्लेनेंट्स, पॉलिटिशियन्स और RTI वाले, या सगळ्यांचाच इशू क्रिएट होतो. वी नीड टू हँडल दोज थिंग्स. आणि ते असताना शाफ्टचं काम करणं म्हणजे एक शाफ्ट करायला वर्ष जातं, जवळजवळ 1-2 वर्ष आम्हाला तो तसंच ठेवून त्याच्यामध्ये काम करावं लागतं. त्याच्यामध्ये मॉन्सूनचं वॉटर लॉगिंग वगैरे इश्यूज असतो. सेफ्टी पॉईंट ऑफ व्ह्यू खूप सांभाळावं लागतं ॲज कम्पेअर टू जर इंटरनल शाफ्ट्स असतील तर. देन फर्स्ट अँड सेकंड वेव ऑफ COVID-19. ॲज ऑल यू नो, COVID-19 सगळ्यांनी फेस केलेला आहे. त्या COVID-19मध्येच आमचा प्रोजेक्ट चालू झालेला होता आणि फर्स्ट लॉकडाऊनच्या वेळेस आमचे सगळे लेबर, ॲज मी अगोदर म्हटलं त्याच्यानुसार ह्याची कॉस्टिंग वाढते, कारण की सेगमेंटल टनलिंग करण्याकरता आपल्याला खूप एक्सपर्टीज लागतात किंवा टेक्निकल स्टाफ जो लागतो तो खूप स्किल्ड लागतो. तर तो स्किल्ड स्टाफ सगळीकडे लोकली अवेलेबल होत नाही खरं तर. आमचा जो लेबर स्टाफ होता, सुपरवायझरी स्टाफ होता, तो घरी पळून गेलेला होता. मग त्यांना आम्ही COVID-19मध्ये ॲक्च्युली एअरलिफ्ट करून रिटर्न आणलं आफ्टर 22 डेज आय गेस, पहिला लॉकडाऊन झाल्यानंतर. कारण की आम्हाला मग तसे इन्स्ट्रक्शन्स मिळाले की तुम्ही आता साईट चालू करा म्हणून. साईट चालू करा, पण रिसोर्सेस काय होते, देर वर नो रिसोर्सेस. मग सगळ्यांना गोळा करा, प्रत्येकाला आमचे ID कार्ड्स प्रोव्हाइड करा, कारण की लोकल मुवमेंटला अलाउन होतं बाहेर पडायला. मग त्यांना IDs द्या, स्वतः पर्सनली जाऊन IDs दिल्यात लोकांना, आम्ही घरातून उचलून आणल्यात, गाड्या प्रोव्हाइड केल्यात आणि तेव्हा कुठे साईट चालू केली आम्ही. आणि तेवढं सगळं झाल्यानंतर पण साईट 6 महिन्याचा एक्सटेन्शन मिळाला कोविडचा, बट तो कंप्लीट करून आम्ही ऑन डेट साईट कमिशन केली विदाउट डिले ऑफ प्रोजेक्ट. थँक्यू. दॅट वॉज कमेंडेबल फॉर आवर साईड. या then 100-year-old building coming under influence zone of the tunnel alignment. So what is influence zone? आपली टनल अलाइनमेंट जाते त्याच्या आयदर साईड ईच साईड 10 मीटर दॅट इज कॉल्ड बफर झोन ऑर अ इन्फ्लुएन्स झोन. त्याच्यामध्ये येणारे सगळे ईच अँड एव्हरी स्ट्रक्चरला आपल्याला बिल्डिंग स्ट्रक्चरल स्टॅबिलिटी करून घ्यावी लागते किंवा त्यांचा सर्वे करावा लागतो की वेदर इट इज सेफ ऑर नॉट, कारण की त्याचा थ्रस्टचा इफेक्ट तिथपर्यंत जाऊ शकतो. तर आमच्या केसमध्ये एक 100 इयर्स ओल्ड बिल्डिंग आम्हाला आली, तेव्हा आम्हाला खूप सारे प्रिकॉशन्स घ्यावे लागले. त्याची पूर्ण स्ट्रक्चरल स्टॅबिलिटी करून घ्यावी लागली. त्याच्यावरती आपल्याला BSM लावावं लागलं, त्याच्यानंतर क्रॅक मीटर लावावे लागले आणि तिकडच्या पब्लिकला की तिकडच्या लोकांना लोकल लोकांना आम्हाला मनाची तयारी करून द्यावी लागली. जर काही उद्भवलंच तर आम्ही भरून देणार आहे, तुम्ही जर काही इश्यू क्रॅक वाटलाच आम्हाला तर आम्ही तुम्हाला शिफ्टिंग करू. तर शिफ्टिंगची अरेंजमेंट आम्ही हॉटेल्समध्ये वगैरे करून ठेवलेली होती. बट देवाच्या कृपेने तसं काही झालं नाही आणि क्रॅक पण आला नाही आणि काही इश्यू झाला नाही, तेवढा थ्रस्ट घेतला नाही. TBM इज मच मोर सेफ याकरताच सांगते, कारण आत्ताच आपण लास्ट वीकमध्ये तुम्ही बघितलं तर न्यूजमध्ये बघितलं असेल, MMRDAने एक टनलचं हे केलेलं आहे, दॅट इज गोईंग अंडरनेथ नॅशनल पार्क. इफ यू कॅन सी ठाणे टू बोरिवली एक टनल होतं आहे, 3 लेनचं आहे, ट्रॅफिक टनल आहे, रोडवे आहे. तर त्याच्यासाठी पण मोस्ट अप्रोप्रिएट इज दिस टनल बोरिंग मशीन. हां, इट नॉट बी EPB, इट मे बी स्लरी TBM बिकॉज खूप मोठा प्रोजेक्ट आहे. बट दिस इज EPB इज मच मोर सेफर साईड. देन विल सी चेंज इन स्ट्राटा. चेंज इन स्ट्राटा हे मी सांगितलं तसंच की जाताना आम्हाला जसं मिठी रिव्हरला आम्हाला जी भरणी मिळाली त्याच्यामध्ये आम्हाला जो सीपेज लागला, सो यू कॅनॉट प्रेडिक्ट की काय येऊ शकेल इन फ्युचरमध्ये. तो हे पण मेन हर्डल होतं. देन चॅलेंजेस ड्यू टू स्मॉलर डायमीटर. आता दिस इज द स्मॉलेस्ट डायमीटर फॉर EPB, कारण की त्याला जो सेटअप लागतो पूर्ण EPBला, कारण की 2 रेल ट्रॅक असतात, एक मॅन कार्ट जाण्याकरता असते आणि एक याच्याकरता असते, आपले मग कार्ट जाण्याकरता असते. आणि 2 ट्रॅकमध्ये लिटरली 50 mm गॅप राहतो, फक्त 50 mm गॅप. एवढी कट टू कट असते त्यांची सगळी अरेंजमेंट. आणि जेव्हा आपण मॅनकार्टमध्ये बसतो तर बसताना यू कॅनॉट सीट लाईक दिस, यू हॅव टू सिट लाईक दिस, म्हणजे तुम्ही बसू पण शकत नाही व्यवस्थित. माझे एक्झिक्युटिव्ह आहेत ते आय गेस 6 feet अबाव असतील. ही यूज टू सिट डाऊन, लिटरली डाऊन, बिकॉज ते बसूच शकत नव्हते. स्पेस कंजेशन खूप मोठा इश्यू होता तो. देन चेंजिंग अ मग कन्वेअर बेल्ट. EPBमध्ये जो मग घेतला जातो तो कन्वेअर बेल्टने घेतला जातो आणि मग तो मग कार्टमध्ये घेतला जातो. तो फ्रिक्वेंटली तुटतो आणि तो रिपेअर करण्याकरता पण खूप डिफिकल्टीज येतात. चेंजिंग कटर हेड. डायमीटर छोटा असल्यामुळे जो कटर हेड चेंज करण्याची जी विंडो आहे ती पण छोटी आहे, त्यामुळे तिथे जाऊन माणूस ते कटर हेड चेंज करणं ॲट द फेस ऑफ द TBM, इट इज ऑल्सो व्हेरी डिफिकल्ट टास्क. देन मग क्लिनिंग, देन मेंटेनिंग एअर क्वालिटी. एअर क्वालिटी मेंटेन करणं एवढ्या छोट्या याच्यामध्ये इट इज व्हेरी डिफिकल्ट जॉब. बट आम्ही दिवसातून आय गेस ट्वाईस अ डे आम्ही एअर क्वालिटी चेक करत होतो बाय मशीन, सेफ्टी पर्सन. देन आपण थ्रू आउट म्हणजे 2 किलोमीटरपर्यंत आपण पूर्ण एअर ब्लोअर्स दिलेले होते, प्रॉपर एअर ब्लोअर्स दिलेले होते. द इश्यू वॉज लाईक आम्ही जो TBM केला किंवा टनल केलं ते ड्युरिंग ह्याच्यामध्ये केलं, कोविडमध्ये केलं. तो वी यूज टू डू दॅट मास्क. जो मास्क लावलं आणि इनिशियल स्टेजेसला N95. इट वॉज लाईक श्वासच घेता येत नाही आहे, फेकून द्या ते मास्क, जाऊ दे हातमध्ये श्वास घेता येऊ दे पहिल्यांदा, असं होतं ते. विल सी द ॲक्च्युअल साईट फोटोग्राफ्स, यू विल लाईक इट होपफुली. विल स्टार्ट विथ द बोर होल्स. This is soil investigation we are doing at the shaft number 3. Next. This is nothing but a 100 mm dia boreholes, nothing new in it. Next. हे बोरलॉक झालेले आहेत, ते आपण चेकिंग करतो की स्ट्राटा काय आहे आणि मग ते आपण इन्व्हेस्टिगेशनला पाठवतो. नेक्स्ट. दिस इज लॉन्चिंग शाफ्ट. दिस इज माय लॉन्चिंग शाफ्ट. इथून मशीन लॉन्च झालेली. दिस इज वेल टाईप स्ट्रक्चर आय वॉज टेलिंग. आणि ही पूर्ण RCC लाईन आहे, लाईनिंग केलेली आहे. 2.1 मीटरची मला वाटतं एक लिफ्ट आपण उचलत गेलेलो होतो, जम्प जम्प किंवा स्लिप फॉर्मवर्क नाही. M50 ग्रेड कॉन्क्रीट आपण यूज केलेलं होतं याच्यामध्ये. नेक्स्ट, दिस इज सेगमेंट मोल्ड. दिस इज ॲक्च्युअल फोटो ऑफ माय साईट. दिस इज ऑल्सो. हे सेगमेंट्स रेडी आहेत टू डिस्पॅच फ्रॉम द कास्टिंग यार्ड. ते कास्टिंग यार्डमध्ये आपण बनवतो, प्रॉपर मिक्स डिझाईन करतो त्याचं, आणि त्याच्यानंतर आपण त्याचं ट्रायल रिंग बनवून त्याचे मेजरमेंट्स घेऊन मग आपण ते डिस्पॅचसाठी रेडी करतो. नेक्स्ट, दिस इज इम्पॉर्टंट पोर्शन, EPB असेंब्ली अँड लॉन्चिंग. हे अशा प्रकारे लॉन्चिंग केली जाते. थ्रस्ट फ्रेमवरती ठेवलं जातं. दिस इज आयसील. आयसील म्हणजे काय आहे की टनलला प्रॉपर जाण्याकरता एक कास्टिंग केलेलं असतं, त्याला प्रॉपर जाण्याकरता. आणि इनिशियली जाण्याकरता आपण ज्या फेसला आहे प्रॉपर एक्सकॅव्हेशन करून घेतो मॅन्युअली, सो दॅट त्याला एक ग्रिप मिळावे. एकदा ग्रिप मिळाले की ते आपोआप कोर करत जातं. मग नेक्स्ट, दिस इज माय टीम, प्रोजेक्ट अँड लेबर स्टाफ. लॉन्चिंगच्या वेळेचा फोटो आहे हा, पूजा वगैरे करताना. नेक्स्ट, हा व्हिडिओ आहे, हा जरा इरेक्शन ऑफ TBM आहे. कॅन सी हा सेगमेंट आहे इरेक्टरच्या सहाय्याने. आणि आवाज खूप जास्त आहे. नेक्स्ट, आफ्टर रिंग बिल्डिंग म्हणजे 4-5 जे सेगमेंट्स आहेत ते एकत्र लावल्यानंतर. ओके, रिंग बिल्डिंग कशी केली जाते, तर रिंग बिल्डिंगमध्ये मी दाखवलं तसं की 5 सेगमेंट्स आहेत. ठीक आहे, 5 सेगमेंटमध्ये एक रिंग येते, याची छोटीवाली एक रिंग असते टॉपला. ती रिंग डिसाईड करते की त्याच्या बाजूने कुठच्या डायरेक्शनला TBM जाणार आहे, आणि दॅट इज ऑलरेडी फीड इन द TBM मशीन. तो जो प्रोग्राम असतो तो ऑलरेडी फीड असतो, आणि तोच प्रोग्राम इंडिकेट करत असतो की रिंगची पोझिशन काय असणार आहे किंवा कीची पोझिशन काय असणार आहे. सो की एकदा फिक्स झाल्यानंतर त्याच्या बाजूचे, सपोज की इज ॲट द टॉप, तर त्याच्या बाजूचे जे सेगमेंट्स आहेत ते पहिल्यांदा लावले जातात, त्याच्यानंतर बॉटमचे लावले जातात. हे प्रोसेस आहे रिंग बिल्डिंगची. नेक्स्ट, हां जाऊ दे. दिस इज ग्राउटिंग. ह्या ग्राउटमध्ये तुम्ही बघितलं तर हे ग्राउट हे स्पेशल ग्राउट असतं. त्याचं मिक्स डिझाईन केलं जातं. आपण मिक्स डिझाईनमध्ये कसं केलं जातं की सिमेंट, वॉटर, बेंटोनाईट याचं मिक्सचर केलं जातं. हे मिक्सचर केल्यानंतर या पाईप थ्रू टाकलं जातं, आणि जेव्हा हे कुंडाला येतं तेव्हा त्याच्यामध्ये सोडियम सिलिकेट इंजेक्ट केलं जातं. वन्स इट इज इंजेक्टेड विदिन अ 17 seconds, इन आर केस विदिन अ 17 seconds इट बिकम्स जेल. जेल बनून जातं, केमिकल रिॲक्शन होते पूर्ण त्याची, आणि ऑटोमॅटिकली पूर्ण रिंगला ते सपोर्ट करतं जेल बनल्यामुळे. अदरवाईज नॉर्मल सिमेंट ग्राउट केल्यावरती ते इट विल नॉट क्रिएट अ सपोर्ट. नॉर्मल ते सिपेज होत राहणार, आतमध्ये जात राहणार. ह्याच्या टेस्ट आपण करतो, विस्कोसिटी टेस्ट करतो, देन स्पेसिफिक ग्रॅव्हिटी करतो, जेल टेस्ट करतो. अशा टेस्ट आपण केल्या जातात, आणि त्याच्यानंतर फायनलाइज करून आपण हे ग्राउटिंग फायनल केलं जातं. आफ्टर प्रायमरी ग्राउटिंग जर आपल्याला कुठे लिकेज सापडलंच पुढे गेल्यानंतर, तर आपण पुन्हा सेकंडरी ग्राउट पण करतो फॉर सेफर साईड, की पुन्हा कुठे लिकेज येऊ नये. आय गेस आम्ही तर सेफर साईड नाही, आम्ही ऑलमोस्ट सगळीकडे सेकंडरी ग्राउट केलंच सेफर साईड म्हणून. नेक्स्ट, विल सी द स्पेस कंजेशन ओव्हर हिअर. ही माझी सब इंजिनियरची टीम आहे ॲक्च्युली. माझे सिनियर आहेत आणि सब इंजिनियरची टीम आहे, आणि हे माझे कॉन्ट्रॅक्टर्स इंजिनियर आहेत. ही मी टेल रिंगच्या मागे आहे, टेल TBMच्या मागे आहे, म्हणजे तिथे तुम्हाला उभं पण राहता येणार नाही आहे. देन इफ यू कॅन सी ही बॅकअप गॅन्ट्री आहे. बॅकअप गॅन्ट्रीच्या म्हणजे टेल TBMच्या इथे जाण्याकरता तुम्हाला बॅकअप गॅन्ट्री 100 मीटर चालत जावं लागतं. त्या एवढ्या छोट्या स्पेसमधनं चालत जावं लागतं. नेक्स्ट. ही मॅनकाट आहे. हा माझा प्रोजेक्ट पार्टनर आहे आणि ही टेल्डिंगचं आहे. बसता येणार नाही तुम्हाला. ब्रेक थ्रू इज मोस्ट इम्पॉर्टंट सेरेमनी फॉर टनल इंजिनियर्स. की एकदा बाहेर पडलो, वी अचीव्ड इट सक्सेसफुली. सो आम्ही सेलिब्रेट करतो ते खूप छान प्रकारे. नेक्स्ट. ब्रेक थ्रूचे फोटो. नेक्स्ट. आफ्टर ब्रेक थ्रू आता फिनिशिंग सुरू होते. दिस इज ॲक्च्युअल टनल आणि ही आपली आहे बेंचिंग. आता कसं आहे, हा त्याच्याकरता आपण एक लाईन बनवतो. त्याला इट इज कॉल्ड बेंचिंग ॲक्च्युली. आणि ही जी आहे, हा जो कलर आहे इट इज कॉल्ड PU कोटिंग. मी जे प्रोसेसमध्ये सांगितलेलं ते आपण फिनिशिंगच्या टायमिंगला PU कोटिंग करतो. नेक्स्ट. आफ्टर PU कोटिंग अँड एव्हरीथिंग स्क्रीन वगैरे लावल्यानंतर, ॲक्च्युली मी स्क्रीनचा फोटो नाही लावला ह्याच्यामध्ये. स्क्रीनिंग वगैरे केल्यानंतर आपण टॉप स्लॅब केला जातो, पॅक करून टाकायला. नेक्स्ट. दिस इज सेगमेंटेड टनलिंग. दिस इज, हे जेव्हा क्लिनिंग चालू होतो तेव्हाचा फोटो आहे, जेव्हा हे 2 ट्रॅक होते क्रॉसिंग करण्याकरता. आणि दिस इज एअर वेंट ब्लोअर जो आम्ही दिलेला होता, हा थ्रू आउट टनल आम्ही दिलेला होता 2 किलोमीटरपर्यंत, टू मेंटेन द एअर क्वालिटी. अँड दिस इज फिनिश टनल. आणि हे जे गॅप दिसतात, हे बोल्ट इंटरलॉकिंग करण्याकरता आपण बोल्ट्स देतो एकमेकांचे सेगमेंट्स लावण्याकरता. हे बोल्ट्स जे जे गॅप्स आहेत किंवा हे आहे, काय म्हणणार आपण, वॉइड्स आहेत, हे आपण स्पेशल ग्राउटने नंतर फिनिशिंग करतो आणि पूर्ण फिनिश करून टाकतो. सो ते असे वॉइड्स राहत नाहीत नंतर खरं तर. दॅट्स इट. थँक्यू. होप मी तुम्हाला बोर नाही केलं.
Thank you so much, ma'am. We really loved the presentation. I will now call upon stage Dr. AP Singh sir to felicitate. Ma'am. Thank you so much. Now I'll call upon stage Dr. Sandeep Potnis, sir. He will brief us about the tunnel engineering course here and tell us about the scope.
Noon, all of you. You have learned about the tunneling techniques, what are the various types, how it is constructed, how it is designed, what are the challenges and all these things. But after learning that, what are the opportunities and what is the scope for this, that I will discuss. I will also discuss about the unique MTech tunnel engineering program at MIT World Peace University. Our program was inaugurated by Shri Nitinji Gadkari, the most innovative and efficient union minister. And in next 10 years, about 5 lakh crores of underground construction will take place in India. So there is a huge scope. Only 4 institutes in India are giving this course of tunnel engineering. And MITWPU is one of them. The various activities we carry out in our program are like this. We conduct workshop, 2 workshops every year where you get opportunity to interact with the industry people. We also conduct site visits, and also 3 months of internship is given to the students on live projects. Our students also participate in various conferences, and they get very good exposure. We met the Metro Man of India during Tunnel Asia conference in Mumbai recently, and our students have presented paper and got prizes in this Tunnel Asia conference. Same. One of our students, Mr. Rakesh Khali, presented paper in World Tunnel Congress, which was recently conducted in Copenhagen. And 10 research papers of our students are selected for the World Tunnel Congress 2023. Next. We also celebrated World Tunnel Day. Our executive president, Rahul Karat sir, was also there. Myself and one of my students participated in the ITS CET professor and PhD meeting and conference. We visited the Herrenknecht factory in Germany. I also visited the lab in Hagerbach lab in Switzerland. Next. We conducted 2 weeks of training for border road organization, young officers. Next. We provide, as I told you, we provide about 3 months of internship to the students at various places. Study tours. Also visited Atal Tunnel with all our students. And most important, recently our student, Mr. Gurneek Singh, he got the package of 24 lakhs. He will be working in a NEOM project, and all our students, we have 100% placement, and they get package of from 6 lakhs to 24 lakhs. So it's a huge opportunity for you. Lot of underground construction will take place. You know, metro will be now in tier 3, tier 4 cities also. There will be hydropower projects. These are some of the people from industry, those who have completed MTech program in our MITWPU, and they are doing very well. We will be organizing one conference in December 2023, that is Advances in Infrastructure Development, and it will be inaugurated by Shri Nitinji Gadkari. I invite you all for this great conference, and you will get opportunity to interact with the most efficient and innovative Union Minister. Thank you all, and let us see a small documentary on Shri Nitinji Gadkari. It is really inspiring. Thank you all.
There are followers, there are leaders, and then there are visionary. Taking people and society to where they ought to be rather than where they want to be is what separates a visionary from a mere leader. Taking off as a minister of the Public Works Department in 1995, Nitin Gadkari made groundbreaking changes in the speed the city of Mumbai traveled. So impressed was the then PM Atal Bihari Vajpayee ji with Gadkari ji's performance as PWD minister that he offered him a responsibility of weaving road nets in the whole of rural India. As India's current Minister of Road Transport Highways, he has re-energized the whole sector with his clear vision. With more than 40,000 kilometers of national highways constructed in the last 7 years, 60,000 kilometers of new roads under his supervision are being constructed. The speed of road construction from a mere 3 kilometers in 2014 has grown to 40 kilometers in 2021. The figures went up from 91,287 kilometers to 1,37,625 kilometers. Going further, INR 3.32 lakh crore is allotted for 22 Greenfield Expressways, initiated by the bridge building messiah, as he is fondly referred to. Bharatmala and Sagarmala, two world-class access-controlled expressway projects led by Nitin Gadkari, are presently in various stages of construction.
मैं ये मानता हूं कि एथिक्स, इकोनॉमी, इकोलॉजी एंड एनवायरनमेंट ये हमारे 3 इंपॉर्टेंट पिलर्स हैं, और इकोलॉजी एंड एनवायरनमेंट को भी प्रोटेक्ट करना और डेवलपमेंट को भी करना.
Multimodal transport system integrates railways, highways, inland waterways and airports, conjuring a highly effective transportation grid, substantially reducing logistic costs and pollution.
जम्मू कश्मीर में करीब 45,000 करोड़ की लागत से 133 किलोमीटर लंबाई की 41 महत्वपूर्ण टनलों का निर्माण कराया जा रहा है. साधना पास सुरंग मार्ग का निर्माण 6.5 किलोमीटर 1300 करोड़, ये जून 2023 में इसका डीपीआर हो जाएगा. मारोक से डिंगडोल के बीच 4 लेन टनल का निर्माण, ये करीब 1100 करोड़ का है. अगस्त 2025 इसका टाइम है, और इसका महत्व देखते हुए इसको जितना कम हो सकता है जल्दी इसकी कोशिश हम कर रहे हैं. डिगडोल से खुनी नाला तक 4 लेन टनल का निर्माण, ये भी करीब 751 करोड़ का है, दिसंबर 2023 में बन जाएगा. खिलानी बाईपास में टनल 1.5 किलोमीटर 750 करोड़, दिसंबर 2023 में पूरा हो जाएगा. अखनूर पुंछ मार्ग पर सुंबल टनल का निर्माण 2.7 किलोमीटर 600 करोड़, अगस्त 2024 में हो जाएगा. अखनूर पुंछ मार्ग पर भीम बरगली टनल का निर्माण 1.1 किलोमीटर 231 करोड़, अप्रैल 2024 में बन जाएगा.
In a historic push for biofuels, Gadkari ji is introducing flex engines which will run on 100% ethanol, directly providing additional income to farmers and the agricultural sector.
हमने ये किया है कि डाइवर्सिफिकेशन ऑफ एग्रीकल्चर टुवर्ड्स एनर्जी एंड पावर सेक्टर. नाउ वी आर फॉर्मुलेटिंग द पॉलिसी by which farmers can make bitumen, and we will purchase from them, and they will get. Now presently the farmers are annadata, After that, we started the green ethanol and other thing. We name it as Urja Data, and now we will make farmer as a bitumen data.
Some of his major work, like unprecedented push for research and development in electric vehicle, leading research and development for usage of waste materials in highway construction to cut down highway construction costs and generate wealth out of waste materials, developing ropeways and funicular railways in the remotest parts of the country, thus boosting tourism. Affable nature goes beyond everyday personal equations as he continues to transmit his radiance and ideas to every individual or organization with his unmatched zeal. Gifted with an ability to dream the seemingly impossible dreams and getting them to fruition also defines this clairvoyant visionary. Nitin Gadkari shines on as one of modern India's pioneering leaders and his work a template for the coming generations. If there ever was the infrastructure man of India, he would answer to the name Nitin Jairam Gadkari.
Thank you so much, sir. I would now request all the students present here to who have participated in the pick and speak competition to gather in class 204, and the quiz competition is going on in the drawing hall. Further, I would request all present here to stay in the campus and enjoy the lunch at 1 p.m. in the canteen. We will continue with this program at 2 p.m. in this same location. Thank you so much for your patience and presence. here who will be taking a seminar on stress management, Dr. Ashwini Indulkar. He is the founder and owner of Revive. He has been awarded by the Doctors Association of Pune for the product she has created named Ujjavati. She has completed a bachelor's in BHMS and also did her post-graduation diploma in cosmetology. With an experience of 14 years and more in the medical research and clinical practices, she has treated more than 3,000 patients with rare and chronic diseases. She has also been awarded with Mahatma Gandhi Puraskar for her COVID Seva. I will now welcome Ms. Ashwini Indulkar ma'am to take the stage.
Very good afternoon to all of you. How was the lunch? Good? So, generally, it's a big task for me because post lunch, we all are bound to feel sleepy because the blood circulation will go to our tummy. But I promise you that I'm going to put you on the edge of your seat. So, the most important task for today, before I'm introducing myself, I'm doing this because in my presentation, there are certain loopholes. Okay? So the student who is very alert, who will notice that loopholes and present it to me, he'll be receiving a special award. So we all are ready for it? Shall we start? Okay. So, am I audible? Okay. So let's begin with our session. Let's introduce myself, Dr. Ashwini Indulkar, and I'm a student of medicine. Okay. So all my life, I'll be always a student of medicine. I have a 14 years of medical clinical practice, and still further I'm doing it, receiving a new experience. So, as I explain myself that I'm a student of medicine, so you are a student of? Okay. So this session, what do you want? I should be like a professor, okay, coming here, preaching, teaching you, or you want to have an interactive session? That's the spirit. Okay? Thank you very much for that. So, when we talk about student, तो student का मतलब हिंदी में क्या होता है? अच्छा एक बात बताइए, इंग्लिश के अलावा आफ्टर इंग्लिश which language is preferable? मराठी की हिंदी? Good one. So for Marathi, please raise your hands. Ah, quite a good amount. Okay, Hindi? Okay. Okay, please raise your hand who all understand Hindi. हिंदी जिसको समझ में आता है प्लीज हाथ ऊपर कीजिए. Okay. So we will do it in Hindi and English. Will it be fine? मराठीत आपण बोलूया. ठीक है? क्वेश्चन आन्सर्स मध्ये आपण मराठीत बोलूया. Done? Okay. So when I am talking about a student, एक विद्यार्थी कैसा होना चाहिए? कैसा होना चाहिए एक विद्यार्थी? तो हमारे संस्कृत में एक श्लोक है, काक चेष्टा बको ध्यानम श्वान निद्रा तथैव च अल्पहारी गृहत्यागी विद्यार्थी पंचलक्षणम. ओके, तो इस श्लोक को हम समझे आज. सबको पता है ये श्लोक? ओके, इस श्लोक का मतलब पता है? ओके, the yes gentleman, I would like to please come. Okay, fine. So please come and okay, you can stand at your place and you can explain me what exactly it is. Yeah, we should appreciate, okay? Yeah, yes sir. Very good, very good. टू गुड. ओके, सो इसका हम बहुत ही अच्छा, बहुत ही अच्छा. आपका नाम सर? ओके, बिग ग्राउंड ऑफ अप्लॉज फॉर अंकित. वेरी नाइस. तो अब हम इस श्लोक को समझते हैं. काक चेष्टा का मतलब होता है, हम सबने बचपन में वो काक की कहानी सुनी है ना, क्रॉ की. वो बेचारा थर्स्टी होता है, वो जाता है, वो पॉट ढूंढता है जिसके बॉटम में पानी होता है, वो कंसिस्टेंटली उसमें कंकर डालता है, ओके, जब तक कि पानी का लेवल ऊपर ना आए और वो पानी ना पिए. तो उसका मतलब ये होता है कि एक विद्यार्थी जो है वो अपने लक्ष्य को पाने के लिए उसमें पेशेंस होना बहुत ज़रूरी है. क्योंकि एक रात में पढ़ के आप तो टॉपर बनने से रहे, तो आपको स्लोली वन स्टेप विथ पेशेंस विथ स्ट्रैटेजिक प्लानिंग पढ़ाई करनी है, राइट. उसके अलावा उस पढ़ाई को करने के लिए जो परिश्रम लगता है, जो हार्ड वर्क लगता है, उस हार्ड वर्क में भी आपकी तैयारी होनी चाहिए. तो एक विद्यार्थी जो है उसको, उसके पास पेशेंस तो होना ही चाहिए, बट अलोंग विद दैट ही शुड बी हार्ड वर्किंग. नाउ सेकेंड इज बको ध्यानम. बगुला, क्रेन, क्या करता है? वो शांति से पानी में खड़ा रहता है. ओके, ही लेट ऑल दो स्मॉल फिश पास. ओके, छोटी छोटी मछलियों को पास करने देता है. एंड एज सून एज ही ग्रैब्स द बिग फिश, ही सीज द बिग फिश, ही ग्रैब्स इट. तो विद्यार्थी जो है, देखिए अगर हम विद्यार्थी हैं तो हमारी लाइफ में बहुत छोटी छोटी समस्या आएंगी. कैसी समस्या होंगी? मैं हॉस्टल में रहता हूँ, मैं घर से दूर हूँ, मैं होमसिक फील कर रहा हूँ, ठीक है, मेरे दोस्तों के साथ मेरी जम नहीं रही है, ये नया शहर है, मुझे फाइनेंशियल प्रॉब्लम है. लेकिन उस बगुले की तरह, उस क्रेन की तरह, वी शुड नॉट बॉदर अबाउट दिस स्मॉल स्मॉल थिंग्स. व्हाट वी शुड डू? We should let pass these small hurdles and we should focus on our big goal. So, काक चेष्टा, बको ध्यानम, श्वान निद्रा. डॉग को सोते हुए सबने देखा है? नहीं देखा? As soon as, जैसे अंकित ने बताया हमें कि he is very alert. जैसे ही थोड़ा सा आवाज आता है, डॉग अपनी आंखें खोल देता है. तो इसका मतलब ये है कि इसका हूबहू निद्रा से नहीं है, लेकिन द स्टूडेंट हैज़ टू बी सो अलर्ट. उसके आजू बाजू जितनी भी चीज़ें हो रही हैं, ही हैज़ टू बी सो अलर्ट. उसको हर चीज़ से ज्ञान अर्जित करना आना चाहिए. अगर आपके टीचर ऐसे ही कुछ बोलते हैं, अगर वो अच्छे टीचर है, तो कोई भी अच्छा टीचर ऐसे ही कुछ नहीं बोलता. ऐसे में भी कुछ नॉलेज है. You have to be alert enough to grasp that knowledge. So, how should be student? श्वान निद्रा की तरह उसका ध्यान होना चाहिए. He should be very alert. अल्पाहारी. अभी अल्पाहारी का मतलब ये नहीं कि आप खाना थोड़ा कम खाइए, नहीं, बिल्कुल भी नहीं है. देखिए, खाना हम अपने आप को हर चीज़ से देते हैं. हम जो देखते हैं, हम जो खाते हैं, हम जो सूंघते हैं, हम जो सुनते हैं, राइट, और हमारी जो कृति है, वो हर चीज़ अपने लिए एक आहार है. तो एक अच्छा स्टूडेंट विल बी वेरी सिलेक्टिव कि वो ये जो आहार दे रहा है अपने पंचेंद्रियों को, वो कौन सी क्वांटिटी में दे रहा है और कितना दे रहा है. तो स्टूडेंट हैज़ टू बी अल्पाहारी, referring to the senses of the organs. Clear? Clear? नींद आ रही है? Now गृह त्यागी. गृह त्यागी का क्या मतलब होता है? भाई घर छोड़ दे, हम सन्यासी बन जाए, ये मतलब है? हम सब के लिए एक अच्छी जगह, जब हम बहुत थक जाते हैं, परेशान हो जाते हैं, मराठीत आपण काय म्हणतो? चल रे, मी खूप दमलो, चाललो मी माझ्या घरी. बरोबर है ना? हिंदी में क्या बोलते हैं? नो यार, मैं थक गया हूँ, मैं जा रहा हूँ अपने घर, राइट. तो घर जो होता है ना, वो कंफर्ट जोन होता है, सबका ही होता है. तो गृह त्यागी मतलब अपने कंफर्ट जोन को त्यागो, राइट. हमें पता है कि 8 बजे सोना अपना कंफर्ट जोन है, पर हमें उसको त्यागना है. 8 बजे तक सुबह सोना कंफर्ट जोन है, हमें त्यागना है उसको। हर वो चीज़ जो आपके और आपके लक्ष्य के बीच में आएगी, हमें उसका त्याग करना है, राइट? तो एक अच्छा स्टूडेंट कैसा होना चाहिए? कंटिन्यू फर्स्ट स्लाइड ऑफ द श्लोक। मेरे साथ ये श्लोक कौन बोलेगा? एक अच्छा स्टूडेंट। आर यू रेडी? हम पढ़ेंगे ये श्लोक, तो चलिए पढ़ते हैं। काक चेष्टा वको ध्यानम त्यागी विद्यार्थी पंचलक्षणम, राइट? अब चलिए भाई, हम अच्छे विद्यार्थी तो बन गए, अब अच्छे विद्यार्थी बन के करना क्या है हमें, राइट? क्या करना है? आगे प्रोग्रेस करना है, हमें अपना गोल साध्य करना है। गोल पता है कहाँ मारा जाता है गोल? कौन से खेल में गोल मारते हैं? राइट, फुटबॉल में। मैंने भी पहली बार फुटबॉल में ही सुना था, ठीक है? तो ये जो गोल है, एक अच्छे विद्यार्थी का गोल कैसा होना चाहिए? स्मार्ट। हाउ इट शुड बी स्मार्ट? स्मार्ट का मतलब एस फॉर स्पेसिफिक। प्लीज बी स्पेसिफिक इन योर गोल। आपकी जो स्टूडेंट लाइफ है वो 4.5, 5, 6 साल की रहेगी, ओके? इसके बाद ये वापस नहीं आने वाली। यू हैव टू बी वेरी स्पेसिफिक। आप अगर सिविल इंजीनियरिंग के स्टूडेंट हैं तो यू हैव टू बी वेरी स्पेसिफिक अबाउट योर करियर एंड अबाउट योर गोल कि नेक्स्ट 3 और 4 ईयर्स में आपका गोल क्या होगा। एम फॉर मेजरेबल। मेजरेबल का मतलब होता है कि उस गोल को साध्य करने के लिए आपके पास उतने जो भी मेजर्स है उसको, उस गोल को साध्य करने के लिए, वो आपके पास अगर नहीं है तो आपको उसकी उपलब्धि करनी है और उस गोल को साध्य करना है। इट हैज़ टू बी मेजरेबल, राइट? तो SMR, R इज रिलेवेंट, ओके? सॉरी, A इज अचीवेबल। अचीवेबल मतलब भाई देखो, अगर आपने 70% फर्स्ट सेमेस्टर में किया है, ठीक है, तो नेक्स्ट सेमेस्टर में आप 80% या 85% अर्जित करने का या फिर उस परसेंटेज को हासिल करने का आप गोल रख सकते हैं। इट हैज़ टू बी अचीवेबल। लेकिन आप फर्स्ट सेमेस्टर में सारे सब्जेक्ट में फेल हो और हम बोलेंगे कि हम यूनिवर्सिटी में फर्स्ट आएंगे, इज इट अचीवेबल? इज इट अचीवेबल? ये तो ऐसा हो गया ना कि आज हमारे प्राइम मिनिस्टर मोदी जी ने क्या बोला है कि 2025 में हमारी जो इंडियन जीडीपी है वो कितनी होगी? 5 ट्रिलियन यूएस। अब हम करंट कौन सी जीडीपी पे बैठे हैं? 3.5, राइट? सो इज इट अचीवेबल है? अचीवेबल है? तो हमारा गोल कैसा होना चाहिए? या हमें राहुल गांधी बनना है? सीधा 10 पे चले, 3.5 से 10। अच्छा, यहाँ पे कोई राहुल गांधी का सपोर्टर तो नहीं है ना? अच्छा, यू आर ओके, हैट्स ऑफ टू यू सर। ठीक है, तो अभी हमारा गोल जो हो गया वो स्पेसिफिक हो गया, ओके? और क्या हो गया? मेजरेबल हो गया। और यस, अब तीसरा क्या होना चाहिए? वो रिलेवेंट होना चाहिए। प्लीज, रिलेवेंट इज वेरी सिंपल। आप MBBS की पढ़ाई करके एक अच्छा सिविल इंजीनियर बन सकते हैं। So it has to be relevant to your own specific field. क्योंकि अगर आप जिस चीज़ में एजुकेशन परस्यू कर रहे हैं उससे रिलेवेंट अगर आपका गोल नहीं होगा तो बेसिकली जो आपने एजुकेशन लिया है it is a waste of time and energy, right? So goal has to be clear and it has to be time bounding. हमें अगर इंजीनियरिंग करना है तो हमें 10 साल में नहीं, 4 साल की डिग्री 4 साल में ही कंप्लीट करनी है। टाइम बाउंड होना चाहिए, होना चाहिए। अच्छा, आप लोगों को एटीकेटी है क्या? गुड, सच में एटीकेटी नहीं है? गुड, सो इट्स अ गुड थिंग। सो योर गोल, हमने एक अच्छा विद्यार्थी सुन लिया। कैसा है विद्यार्थी? हाँ, राइट। राइट राइट, आप बोल सकते हो, प्लीज से इट, आई बी वेरी हैप्पी. काकचेष्टा बको ध्यानम श्वान निद्रा तथैव च. आगे, अल्पहारी गृहत्यागी विद्यार्थी पंचलक्षणम. तो एक अच्छे आइडियल विद्यार्थी ने क्या कर लिया, एक अच्छा सा गोल भी सिलेक्ट कर लिया. हो गया गोल. अब हम देखेंगे कि इस अच्छे विद्यार्थी और उसके आइडियल गोल जो है उसके बीच में हिंडरेंस क्या है हिंडरेंस है, तो उसको एड्रेस करें अभी. ओके, तो थिंग इज लाइक दैट कि जब हमने देखा कि जो हमारा गोल है वो फुटबॉल टीम में होता है. सो फुटबॉल टीम में 2 टीम्स होती है ना. एक टीम क्या करती है, एग्जैक्टली आपको गोल करने से रोकती है, वो कौन होती है, अपोजिट टीम. और जो आपको गोल करने में सपोर्ट करती है वो कौन सी होती है, सपोर्टिंग टीम. तो विल स्टार्ट विद द अपोजिट टीम. क्या क्या है अपने अपोजिट टीम में, yes. आप सबके पास फॉर्म पहुंच चुके हैं, राइट है ना. उसके ऊपर क्वेश्चन भी है. अरे बी ऑनेस्ट, अगर आप वो प्रोक्रेस्टिनेशन फील कर रहे हैं तो प्लीज लिखिए कि हाँ मैं कर रहा हूँ, क्योंकि आपके गोल और आपके बीच में सबसे इम्पोर्टेंट पॉइंट और सबसे बड़ा हिंड्रेंस आएगा प्रोक्रेस्टिनेशन. सेकंड, अनविलिंगनेस. थर्ड, लेजीनेस. ओके, इट्स माय टेस्ट नाउ. ओके, थर्ड इज लेजीनेस, fourth is addictions, right? And the fifth one is a lack of self care. Okay, हम इसको एक पॉइंट एक्सप्लेन करेंगे. नाउ विल सी कि हमारी सपोर्टिंग टीम में क्या है. क्या है हमारे सपोर्टिंग टीम में, डिसिप्लिन, सेल्फ डिसिप्लिन. अच्छा, मैं फिर से एक बार याद दिलाती हूँ, मेरे प्रेजेंटेशन में 3 से 4 गलतियाँ हैं, आपको वो निकालनी है, राइट? और जो ये निकालेगा उसको एक स्पेशल प्राइज मिलेगा. सो अपनी सपोर्टिंग टीम में है डिसिप्लिन, विलिंगनेस, सेल्फ केयर, क्लैरिटी ऑफ द थॉट्स, फैमिली एंड टीचर्स. इसका मैं एक छोटा सा एग्जांपल दूँ आपको. जब मेरा ये सेशन फिक्स हुआ था, राइट, तो जनरली आई टेक सेशंस जो मेरे हिसाब से होते हैं, बट आपके कुछ टीचर्स हैं, मैं उनका नाम इस बार लूँगी. इस बार कुलकर्णी सर, AP सिंह सर, मनीष दीक्षित सर, विकास पाटिल सर. स्पेशली कुलकर्णी सर ने ही मेड एफर्ट्स टू मेक अ कॉल टू मी एंड ही सेड कि ये 2 दिन के फीस्ट में मैं आपका सेशन रख रहा हूँ, तो मुझे अपने विद्यार्थियों को गाइड करना है, इसलिए उन्होंने कुछ पॉइंट्स दिए. सो your supporting team is really solid. Okay, so big round of applause for your supporting team. Okay, so you guys are absolutely blessed. So हम देखते हैं अभी supporting and opposite team हमें clear है. बोरिंग हो रहा है क्या, नहीं हो रहा है, करें क्या? ओके, सो चलिए हम अपोजिट टीम में देखते हैं. प्रोक्रेस्टिनेशन. सी प्रोक्रेस्टिनेशन बेसिकली कुछ नहीं होता है, ठीक है, मैं भी करती हूँ, आप भी करते हैं. इट्स अ ह्यूमन नेचर. चीज़ों को लेट करने की आदत होती है हमें, राइट? असाइनमेंट है ना, 15 सितंबर को देना है, 15 अगस्त को हमें पता है, ठीक है, फिर भी वो असाइनमेंट्स हम कंप्लीट करेंगे, शुरू करना करेंगे 12 सितंबर को, राइट? 12 या 13 सितंबर को. एक कुछ तो भी बोलो. अच्छा, आप मुझसे भी आगे हो. 14 सितंबर, वाव, वेरी नाइस. इससे बोलते हैं प्रोक्रेस्टिनेशन, राइट? सो बेसिकली इट्स अ ह्यूमन नेचर. इसमें डरने वाली कोई बात नहीं होती है, क्योंकि प्रोक्रेस्टिनेशंस के अपने रीजंस होते हैं, लेकिन इसके लिए उसको इग्नोर नहीं करना है, बिकॉज यही प्रोक्रेस्टिनेशन आपको बैड आदत में, गलत आदतों में भी लगाएगा, आपको लाइफ में फ्रस्ट्रेशन भी क्रिएट करेगा, और आपको जो एकेडमिक एक्सीलेंस होता है उसमें भी सबसे बड़ा हिंड्रेंस जो बनता है वो है प्रोक्रेस्टिनेशन. उसको पहले देखिए कोई भी चीज़ होती है ना, उसको पहले एक्सेप्ट करते हैं, ठीक है। अगर हमने उसका अस्तित्व ही नकार दिया तो हम उसके ऊपर कुछ काम नहीं कर पाते। पहले हम उसको एक्सेप्ट करेंगे कि हाँ भाई प्रोक्रेस्टिनेशन की प्रॉब्लम है ना? किसको किसको है? मुझे भी है, आई एग्री। सी, सो इसको हम बेसिकली इसको हम सोचते हैं कि भाई क्यों होता है ये प्रोक्रेस्टिनेशन, इसके रीजंस क्या है और हमें इसको एड्रेस क्यों करना है। हमारा एकेडमिक एक्सीलेंस तो है ही, बट सबसे मोस्ट इम्पॉर्टेंट बात ये होती है कि जब प्रोक्रेस्टिनेशन होता है ना, उसमें जो टाइम हमारा जाता है, राइट, दैट लॉस्ट टाइम विल नेवर गेट बैक। सो we have to stay in present, we have to save that time. So procrastination, to address procrastination is very important. और 10 बार बोलूं प्रोक्रेस्टिनेशन तो समझ में आ जाएगा। ओके, सो प्रोक्रेस्टिनेशन का सबसे बड़ा प्रॉब्लम होता है, क्यों होता है? फियर ऑफ परफेक्शन। जैसे अगर मैं अपना एग्जांपल दूं, आई एम वर्किंग दिस स्ट्रेस मैनेजमेंट एंड एज अ लाइफ कोच ऑलमोस्ट फॉर अ डिकेड। बट द प्रॉब्लम वाज दैट कि जब मैंने पहले तो मेरे पास पूरा मटेरियल रेडी था, मेरे पास डिग्री भी थी, सब था, सब कर लिया मैंने, और मेरे पास अपॉर्चुनिटीज़ भी आती। आई ऑलवेज यूज टू गेट द अपॉर्चुनिटी टू एड्रेस द सेशन, बट मैं अवॉइड करती थी, मैं किसी और को दे देती थी। देन वन फाइन डे माई फ्रेंड हैज़ कम टू मी एंड शी सेड, सी योर कंटेंट इज सो गुड, यू कैन टॉक सो वेल, व्हाई यू आर नॉट यूजिंग दिस अपॉर्चुनिटी? एंड देन आई रियलाइज कि सीरियसली व्हाई आई एम नॉट यूजिंग इट? And then I realized I have a problem of perfection, because I always used to avoid those sessions. I used to feel कि नहीं, I may not be a perfect, I'm not able to deliver it perfectly, right? So I used to avoid, I used to that is called procrastination, right? Delay करो, सब कुछ होने के बावजूद delay करो. So basically perfection is a myth. ओके, ये हमने आपने बनाया हुआ, किसी और ने सोसाइटी में बनाया हुआ परफेक्शन इज अ मिथ। कोई परफेक्ट नहीं होता है, मैं भी परफेक्ट नहीं हूँ, आप भी परफेक्ट नहीं है, लेकिन परफेक्शन अचीव किया जा सकता है बार बार प्रैक्टिस से। ओके, अगर मैं ऐसे 100 सेशंस लूंगी तो मैं परफेक्ट हो जाऊंगी? तो आप एक ही लेसन 10 बार करेंगे तो परफेक्ट हो जाएंगे? ओके, सेकेंड, फियर ऑफ फेल्यूर। फियर ऑफ फेल्यूर इज़ वेरी कॉमन कि भाई मैं ये काम करते हुए अगर फेल हो गया तो फिर क्या आगे? मेरा असाइनमेंट में करने, अभी असाइनमेंट का जो है ना प्रोक्रेस्टिनेशन, उसका एक लाइट एग्जांपल है, बट जनरली हम जब पढ़ाई करने बैठते हैं तो वो एक प्रॉब्लम होती है कि अब मैं फेल हो गया तो एग्ज़ाम में मैं नहीं कर सकता, अगर मुझे डिलीवर करना नहीं आया था, तो फियर ऑफ फेल्यूर। एंड द लास्ट इज़ अ लिविंग एनवायरनमेंट। लिविंग एनवायरनमेंट फिजिकल एंड मेंटल इज वेरी इंपॉर्टेंट। आपको क्वेश्चन पूछना है? ओके, सो लिविंग एनवायरनमेंट का मतलब होता है कि हम सब ने सुना है कि अगर आप 5 अच्छे दोस्तों के साथ बैठोगे तो आप 6वें अच्छे दोस्त बनोगे। अगर आप 5 गुंडों के साथ बैठोगे तो अगर आप गुंडे नहीं भी बने तो भी आपका नाम उसी श्रेणी में लिया जाएगा या नहीं? ठीक है, सो दिस इज कॉल्ड लिविंग एनवायरनमेंट। नाउ एग्जाम्पल और, मुझे पता है कि 10 दिन के बाद मुझे असाइनमेंट देना है, हम रूम पे बैठे हैं, मैं असाइनमेंट कंप्लीट कर रहा हूँ, मेरा एक दोस्त आके मुझे बोलता है चल छोड़ ना, एक सिगरेट पी के आते हैं। ठीक है, अगर 3 दोस्त 4 लोग आप बैठे हो रूम में और उसमें से 3 बोले चल छोड़ सिगरेट पी के आते हैं, 3:1, आप जाओगे या नहीं जाओगे? जो नहीं जाएंगे उनका विल पावर बहुत अच्छा है, मुझे आके मिलना और जो जाएंगे वो प्रोक्रेस्टिनेट करेंगे, राइट? करेंगे या नहीं करेंगे? करेंगे या नहीं करेंगे? सो एनवायरमेंट, फिजिकल एंड अ कंपनी, जीवित और जो भी स्थानबद्ध एनवायरमेंट है, दैट इज वेरी इंपॉर्टेंट फॉर द स्टूडेंट। स्टूडेंट लाइफ के लिए एनवायरनमेंट बहुत इंपॉर्टेंट होता है। क्लियर? यहाँ तक क्लियर है? आगे बढ़े। प्रोक्रेस्टिनेशन के सॉल्यूशन, डिस्कवर व्हाई यू प्रोक्रेस्टिनेट, आपके फॉर्म्स पे लिखा है, लिखा है आपके फॉर्म्स पे, तो प्लीज़ उसका रीज़न बता दीजिए। जैसे मैंने बताया कि शायद मैं परफेक्शन की तरफ ज़्यादा इंक्लाइन थी, इसीलिए मैं प्रोक्रेस्टिनेट कर रही थी। आप अपना रीज़न ढूंढिए और प्लीज़ फॉर्म फिलअप कीजिए। रिकग्नाइज फियर वी कैन डील विथ, डेफिनेटली। अगर आपको फेलियर का फियर है, देखिए वो बच्चा एग्ज़ाम से डरता है जिसने पढ़ाई नहीं की है। अगर आपके पास 10 सब्जेक्ट्स हैं टेंटेटिवली, उसमें से 5 सब्जेक्ट आपको बहुत पसंद है और 5 सब्जेक्ट आपको बिल्कुल पसंद नहीं है, राइट? तो आप क्या करेंगे? जो पसंद है वो पढ़ेंगे और जो नहीं पसंद है उसको प्रोक्रेस्टिनेट करेंगे। करेंगे? आप देखिए जिसमें आपको बिल्कुल इंटरेस्ट नहीं है वो सब्जेक्ट और वो प्रोक्रेस्टिनेट हो गए, मतलब एग्जाम के 8 दिन पहले आप वो 5 सब्जेक्ट कंप्लीट कर पाएंगे? सो recognize your fear, dislikings and deal with it. Next, कांचना जी मेरी स्लाइड्स इतनी भी नहीं है, सो प्लीज कोऑपरेट। अच्छा, नेक्स्ट पॉइंट स्लाइड नहीं है पर कोई बता सकता है क्या मुझे? किसी ने पढ़ा था? नहीं, पीछे वाला स्लाइड। मेक एन हैबिट टू वर्क ऑन योर प्रोजेक्ट। जैसे कि आपको अगर कोई चीज़ पसंद नहीं है, मुझे दौड़ना पसंद नहीं था, आई मेड अ हैबिट कि मैं हर रोज़ 10 मिनट दौड़ूं, ठीक है? तो अगर आपको कोई सब्जेक्ट पसंद नहीं है, सो प्लीज़ ट्राई योर लेवल बेस्ट कि सिर्फ 10 मिनट वो सब्जेक्ट आप पढ़ो। उसका साइकोलॉजिकल रीज़न ये है कि इंसान उस चीज़ को तब तक ही डिसलाइक करता है, द पर्सन विल डिसलाइक दैट पर्टिकुलर थिंग बिकॉज ही इज़ हैविंग नो अंडरस्टैंडिंग अबाउट दैट पर्टिकुलर सब्जेक्ट। So, if you do it religiously, 10 minutes a day, what will happen? You will read that subject at certain amount, spending after certain amount of time, you will have an understanding about that subject and you will start having interest in that subject. This is a cycle. So, if you create this cycle, it is mandatory to spend that 10 minutes daily. Okay? And uske baad 1 or 2 hours. That is more than enough. क्लियर? आगे चले? प्रोक्रेस्टिनेशन क्लियर हुआ? ओके, एक काम करते हैं, बहुत सारे लोग ना स्लीपी हो गए हैं, मैं पानी पी लेती हूँ, तब तक आप मुझे ज़ोर से क्लैप करके दिखा दीजिए, और वो आवाज़ इतनी ज़्यादा होनी चाहिए ना कि जो सोए हैं ना आपके आजू बाजू उनकी भी नींद उड़ जानी चाहिए। ओके, सो 1 2 3। Thank you. You all are such a good student. Very obedient. MIT really working hard on you, huh? Really nice. Pardon? Okay. So the second is laziness. See, there is a difference between laziness and procrastination. करे टॉपिक पे आए या नहीं आए? ब्रेक ले ले, 5 minutes, 2 minutes, चाय का ब्रेक। सो ओके, चहा बिस्किट सगळं आपण देऊया, फक्त थोडेसे 10 मिनिटं वाट बघा. ओके, सो द थिंग इज लाईक दॅट. प्रोकॅस्टिनेशन नंतर लेझीनेस आलाय, बट लेझीनेस अँड प्रोकॅस्टिनेशन देर इज अ डिफरन्स. व्हॉट इज अ डिफरन्स? कॅन एनीबडी गेस और टेल मी? Difference between procrastination and laziness. Nice, very nice. What's your name, sir? Rishikesh. Okay, so he is actually having clear concept about laziness. That means you are working on yourself and you know better. So in procrastination the goal is set, and in laziness the goal is not set. So what happens in procrastination, you are bound to do the things, भले वो लेट करें आप, लेकिन आपको वो चीज़ करनी है ना, असाइनमेंट्स कंप्लीट करनी है. बट लेजीनेस में you are not even implanting a thought to complete that particular thing. So this is a difference between procrastination and laziness. So laziness is more harmful than the procrastination. So उसको address करना भी बहुत ज़रूरी है. And why we are lazy? Because Kanchana ji, you are giving me tough time. Why we are lazy? Because we have a lack of interest. हमें उस सब्जेक्ट में इंटरेस्ट ही नहीं है, राइट? तो फिर हम वो सब्जेक्ट क्यों पढ़ें? फर्स्ट. सेकंड होता है लो सेल्फ एस्टीम, कि मुझसे होगा ही नहीं, मैं कर ही नहीं पाऊंगा. दिस इज कॉल्ड लो सेल्फ एस्टीम. थर्ड वन इज अ फटीग. फटीग इज अ फिजिकल सिम्टम. फटीग का मतलब होता है कि आपके बॉडी में किसी मिनरल्स एंड विटामिन्स या फिर आपकी बॉडी इतनी ज़्यादा एक्सर्ट कर रखी है कि यू हैव अ कंप्लीट फिजिकल फटीग. तो उसकी वजह से क्या होता है? यू डोंट फील लाइक डूइंग एनीथिंग, यू बाउंड टू फील लेजी बिकॉज ऑफ दैट फिजिकल सिम्टम. एंड द लास्ट वन इज इग्नोरेंस. भाई इग्नोरेंस इज द वेरी बैड थिंग. कल करे सो आज करे सो. हाँ, इग्नोरेंस में क्या होता है भाई? आज करे सो कल कर, कल करे सो परसों, ऐसी ही जिंदगी बीतेगी हमारी बरसों, राइट? सो इग्नोरेंस इज वेरी बैड थिंग. जिनका ये एटीट्यूड है ना कि चलो भाई कर लेंगे, जो होगा सो होगा, बाद में देखेंगे, स्टूडेंट लाइफ, दिस इग्नोरेंस विल लीड टू अ difficult situation, and laziness is one of the symptom those who are having a ignorance towards their future. So इसके solution क्या है? Eat that frog first. इसका मतलब क्या होता है? frog को खाना है हमें? नहीं तो क्या करें? Yes, ऋषिकेश जी आपने बहुत पढ़ाई की है. ओके, सो ईट दैट फ्रॉग फर्स्ट मतलब जो तुम्हें सबसे डिफिकल्ट लगता है बस उसी को पहले पिक करो और उसी से काम शुरू करो. कैसे शुरू करना है? लास्ट वाले इसमें बताया था 10 मिनट्स एवरी डे देके, राइट? 10 मिनट्स. सेकंड आप ही बता दो, सेकंड क्या है? कंप्लीट योर डिफिकल्ट सब्जेक्ट. सो डेफिनेटली राइट. और कंप्लीट योर डिफिकल्ट सब्जेक्ट, ट्राई 10 मिनट्स. ये वाला ट्रिक भी बता दिया है. अच्छा, एक और ट्रिक है. ओके, ये ट्रिक ये है कि जब आपको ऐसा लगे कि ये कोई डिफिकल्ट सब्जेक्ट, जब हम पढ़ाई करने बैठते हैं ना, हम पढ़ाई को लेके बात करेंगे बिकॉज यू आर अ स्टूडेंट, राइट? तो जब आप कोई डिफिकल्ट चीज़ करने बैठते हैं ना, तो विद इन 5 सेकेंड्स, विदाउट थिंकिंग, without giving a pause to your brain, you should immediately start doing that thing, because after 5 seconds your brain will give you a nice excuse not to do that thing or to procrastinate that thing, right? So this is a key. अगर आपको पता है, आपने अगर डिस्टिंग्विश कर लिया है कि आप प्रोक्रेस्टिनेट करते हैं, आप प्रोक्रेस्टिनेट क्यों करते हैं, किस सब्जेक्ट में करते हैं, तो दिस इज द ट्रिक टू सॉल्व दैट प्रोक्रेस्टिनेशन प्रॉब्लम. क्लियर? हेल्पफुल? ओके, सो 10 मिनट्स वाला तो हमने दे दिया. उसके बाद क्या करना है लेजीनेस को मिटाने के लिए? कांचना जी, ओके, बी मोर रियलिस्टिक. बी मोर रियलिस्टिक का मतलब क्या होता है कि देखिए, अगर आप लेजी है, अगर आप उस चीज़ को लेके या प्रोक्रेस्टिनेशन को लेके अगर आप फाइट कर रहे हैं, तो आप दिन में गोल्स बनाएंगे. अब दिन में 12 घंटे में आप 10 गोल्स लेंगे तो पूरे कर पाएंगे? कर पाएंगे? नहीं कर पाएंगे, राइट? तो आपको बहुत रियलिस्टिक होना है और 2 से 3 गोल्स अपने आप को देने हैं और उस गोल्स को कंप्लीट करने की जिम्मेदारी लेते हुए उस गोल्स को कंप्लीट करना है. दैट्स द बी मोर रियलिस्टिक. अच्छा, अभी तक किसी ने देखिए मेरे इसमें और क्या था? Very good. That girls are dominating boys, okay? They are having more minute observation than you guys. Family में जो A missing था, वो उन्होंने notice किया है, okay? Double A था क्या? Okay. Very nice. So you guys are attentive, okay? You are taking out all the difficulties and all the problems from my solutions also. So be more realistic or realistic? Realistic, okay? Now, जैसे हमने पहले भी बोला कि environment is very important. Environment, देखिए environment जो होता है ना, जो मैंने जैसे आपको बताया कि आप जहाँ हो, आप जिस कंपनी में हो, उस कंपनी को हम environment की तरह ही गिनेंगे, right? So, एक तो आपकी कंपनी कैसी है? So I'm not saying every student is having their own journey and own character, but be more specific. अगर आपको आपके लाइफ के गोल क्लियर है और आप उस गोल्स तक पहुंचना चाहते हैं, तो अपने जो फ्रेंड्स हैं ना, वो बहुत ही कॉन्शियसली चूज कीजिएगा, राइट? ये कर पाएंगे हम? ओके। दूसरा जो होता है कि पीक एनर्जी टाइम करके एक कंसेप्ट है, जैसे कि देयर आर सम स्टूडेंट्स जो मॉर्निंग अर्ली राइजर्स होते हैं, अर्ली मॉर्निंग में उनका जो एनर्जी लेवल होता है बहुत अच्छा होता है, उनके लिए वो पीक एनर्जी टाइम है, ठीक है? लेकिन कुछ स्टूडेंट्स होते हैं दे आर वेरी कंफर्टेबल, जो रात में पढ़ाई करते हैं। निशाचर बोले हम उनको? नहीं, वो उनका कैरेक्टर है, ठीक है? सो उनको निशाचर नहीं बोला जाता। शाहरुख खान ऑलवेज अवेक एट नाइट and he is more creative at night, right? ये एग्जाम्पल सही है? So आपके आजू बाजू भी आपके ऐसे फ्रेंड्स रहते होंगे जो रात में पढ़ाई करना बहुत ज़्यादा पसंद करते हैं, तो उनके लिए वो जो मिडनाइट आवर्स होते हैं वो उनके पीक एनर्जी आवर्स होते हैं। So हमें क्या करना है, ये जो पीक एनर्जी आवर्स हैं वो हमें पिक करने हैं, और उस पिक एनर्जी आवर्स में जो हमें सबसे डिफिकल्ट सब्जेक्ट लगते हैं हमें वो पढ़ने हैं, राइट? कर सकते हैं हम? नाउ जब हम एनवायरनमेंट की बात करते हैं तो फिजिकल एनवायरनमेंट की बात करते हैं, राइट? सो जब जहाँ पे हम पढ़ रहे हैं, ओके, एवरीथिंग इज हैविंग एनर्जी, नेगेटिव और पॉजिटिव, राइट? तो एक गंदा सा सड़ा हुआ सा बदबूदार कमरा कैसे एनर्जी देगा आपको? आपका कंसंट्रेशन बढ़ेगा पढ़ाई में, लेकिन एक साफ सुथरा क्लीन कमरा, खुशबूदार तो नहीं बोल सकते, बट क्लीन स्मेल वाला कमरा कैसे लगेगा? यस, सो दैट इज द मोस्ट इंपॉर्टेंट थिंग। जहाँ पे आप पढ़ो वो जगह एब्सोल्युटली क्लीन, क्वाइट एंड ऑर्गेनाइज्ड होना बहुत ज़रूरी है। गाइस ट्रस्ट मी, आप कहीं हॉस्टल में रहते होंगे, आप रूम लेके रहते होंगे, अगर आप अभी से ऑर्गेनाइज्ड होंगे, आपकी वो ऑर्गेनाइज्ड करने की, चीज़ों को ऑर्गेनाइज्ड रखने की एनर्जी आपके लाइफ में दिखेगी आपको। आपकी लाइफ विल बी एब्सोल्युटली ऑर्गेनाइज्ड। हर चीज़ के लिए एक अलग समय होगा, हर चीज़ के लिए अपना अलग पड़ाव होगा, एंड यू विल बी हैविंग बेस्ट ऑर्गेनाइज्ड बैलेंस लाइफ। सो हमें ज़िंदगी में ऑर्गेनाइज रहना ज़रूरी है या नहीं? लेक्चर के बाद भूल जाएंगे। ये लेक्चर था, गुड। सो उसके बाद एनवायरनमेंट में आता है, कांचना जी आप ही हेल्प कर दीजिए अभी। गेट रीड ऑफ डिस्ट्रैक्शन। क्या डिस्ट्रैक्शन? जैसे हमने बोला था ना, कौन सा? अल्पाहारी। विद्यार्थी कैसा होना चाहिए? अल्पाहारी। तो हमारी कहाँ हमें डिस्ट्रैक्शन को कंट्रोल करना है? आँख। क्या सुन रहे हैं, क्या देख रहे हैं, क्या बोल रहे हैं, हमारी एक्शंस क्या है, हमारी कृति क्या है, राइट? सो इस अल्पाहारी का ही ये है कि गेट रीड ऑफ डिस्ट्रैक्शन। तो हमारे लिए अभी एट दिस मोमेंट सबसे बड़ा डिस्ट्रैक्शन क्या होता है? तो मोबाइल को क्या करना है? आग लगानी है तो क्या करना है? अवॉइड करना नहीं है, मोबाइल को एड्रेस करना है, किसी भी चीज़ को ज़िंदगी में अवॉइड नहीं किया जा सकता। मोबाइल को एड्रेस कीजिए कि हाँ, एक्सेप्ट कीजिए कि ये डिस्ट्रैक्शन है, ये मेरे गोल की तरफ जाने के लिए बहुत बड़ा हिंड्रेंस है, अभी मुझे अपने गोल के लिए मेहनत करनी है, तो अब मैं इसको बंद कर दूंगा। और बंद करने से पहले अपने फैमिली को फ़ोन कर दीजिए, बताइए कि 3 घंटे के लिए मेरा मोबाइल बंद रहेगा, वरना वो लोग पैनिक हो जाएंगे। एक अच्छा स्टूडेंट रिस्पॉन्सिबल भी होता है, राइट? तो हम करेंगे ये डिस्ट्रैक्शन, इस डिस्ट्रैक्शन को पकड़ेंगे या अवॉइड करेंगे? पकड़ेंगे, एड्रेस करेंगे और फिर उसके ऊपर काम करेंगे, राइट? राइट? नाउ लास्ट वन, फोकस ऑन टास्क फॉर स्पेसिफिक। ये तो हमने बहुत बार बोल लिया, राइट ना? मैंने 10 मिनट का मंत्रा दे दिया, 5 सेकंड्स का मंत्रा दे दिया, उस टास्क को मैंने अलग अलग डिफरेंट इसमें टाइम जोन में डाल के उसको स्मॉल फ्रेगमेंट्स में भी बता दिया। इसके ऊपर और बात करूं मैं? करनी है? बॉयज बोल रहे हैं ना और गर्ल्स में आवाज आ रही है हाँ। रेज योर हैंड्स। किसको किसको चाहिए? ओके सर, ओके, वेरी गुड। सो फोकस ऑन टास्क फॉर स्पेसिफिक पीरियड ऑफ टाइम। सी, अगर आपको एक सब्जेक्ट है, ओके, वो बहुत डिफिकल्ट जा रहा है, वो आपके लिए टास्क हो गया, क्लियर? अब वो टास्क, जैसे मैंने 10 मिनट का मंत्रा बताया था, वो टास्क अगर आप एवरीडे 10 मिनट उस सब्जेक्ट्स को देते हैं तो इट इज़ बाउंड टू हैपन, एवरीडे 10 मिनट स्पेंड करने के बाद आपको उस सब्जेक्ट का अंडरस्टैंडिंग आता है। जो चीज़ हमें अंडरस्टैंड होने लगती है, उस चीज़ में हमें इंटरेस्ट आने लगता है, और जैसे ही हमें उस चीज़ में इंटरेस्ट आने लगता है, हम उस चीज़ के ऊपर 10 मिनट से ज़्यादा टाइम स्पेंड करते हैं। सो फर्स्ट 1 वीक में आप 10 मिनट स्पेंड करेंगे, उसके बाद वो अपने आप ही 20 मिनट्स होगा और 1 आवर होगा, टिल द टाइम यू फिनिश दैट टास्क। क्लियर? क्लियर? नाउ सेल्फ केयर। सेल्फ केयर इज़ द मोस्ट इम्पॉर्टेंट थिंग। भाई, आप स्टूडेंट हो, आपको सेल्फ केयर करना बहुत ज़रूरी होता है, राइट? एज अ ह्यूमन वी हैव टू केयर आवर सेल्फ। पहले तो ये समझना है कि टारगेट्स अचीव करने से और बहुत ज़्यादा मार्क्स लाने से ज़िंदगी में खुशी नहीं मिलेगी, राइट? मिलेगी? क्योंकि एक सेमेस्टर में अगर आपने बहुत अच्छे मार्क्स लाए तो आपके लिए दूसरा सेमेस्टर भी है, वो आपका गोल होना चाहिए, बट योर हैप्पीनेस शुड नॉट बी रिलेटेड टू अचीवमेंट्स ऑफ द गोल, इट शुड बी द बाय प्रोडक्ट ऑफ अचीविंग द गोल, राइट? ये समझ में आ रहा है? ये बहुत ज़्यादा हो रहा है, ज़्यादा हो रहा है, ये स्टेटमेंट ज़्यादा हो गया। कि आप गोल सिलेक्ट कीजिए, लेकिन ऐसा नहीं होना चाहिए कि अगर मुझे वो गोल मिल गया, अगर मैंने वो गोल हासिल कर लिया, इफ आई अचीव दैट गोल देन ओनली आई विल बी हैप्पी। नो, योर हैप्पीनेस शुड नॉट बी रिलेटेड टू दैट गोल, इट शुड बी द बाय प्रोडक्ट ऑफ दैट गोल। यू गिव योर 100%, you try your level best, you take this kind of a session to achieve your goals, okay? Take a guidance from your teacher, okay, and try to achieve that goal. अगर एक बार में नहीं होता है, go easy on yourself, it's okay, it's okay, we'll try again and we'll try to achieve that goal again. बट ये नहीं होना चाहिए कि मैंने इतनी मेहनत कर दी और अब मुझे गोल नहीं मिला, मेरा, मैं अपना गोल अचीव नहीं कर पाया, अब मैं गया डिप्रेशन में। ये होना चाहिए? अगर आपने वो गोल अचीव कर लिया तो वी विल सेलिब्रेट, राइट? बट अगर आपने नहीं किया तो एटलीस्ट यू शुड बी हैप्पी दैट यू ट्राइड टू अचीव दैट गोल। वो जो मेहनत आपने की है ना, वो मेहनत ज़ाया नहीं जाने वाली। आपको वो गोल नेक्स्ट टाइम अचीव करने के लिए सिर्फ 30% मेहनत करनी पड़ने वाली है। क्लियर? सो हैप्पीनेस शुड बी द बाय प्रोडक्ट ऑफ। सो गए सब लोग? चलो, लेट्स क्लैप वन मोर टाइम। ये वाला तो बहुत, यहाँ पे सारे सो रहे हैं। आई अंडरस्टैंड ये थोड़ा थियोरटिकल है, थोड़ा मोनोटोनस हो जाता है, ओके, बट ये पढ़ना भी ज़रूरी है ना. प्रोक्रेस्टिनेशन नहीं कर सकते हम लोग सेशन में, कर सकते हैं क्या? सब जग गए अभी? ओके. सो नेक्स्ट टाइम यू डाउट योर सेल्फ. जैसे मैंने बोला था, देर इज नो परफेक्शन. परफेक्शन इज अ मिथ. नो बडी इज परफेक्ट. ना आप परफेक्ट है ना मैं परफेक्ट हूँ, राइट? बट परफेक्शन अचीव किया जा सकता है. सेल्फ क्रिटिसिज्म एब्सोल्युटली नो. कर सकते हैं हम सेल्फ क्रिटिसाइज अपने आप को? मुझसे होगा ही नहीं, मैं ऐसी ही हूँ, मेरे से तो होता ही नहीं है, ये करना है? नो. इंस्टेड ऑफ दैट यूज गुड अफर्मेशन. आई एम गुड, आई एम डूइंग गुड, आई विल बी द बेस्ट, आई एम द बेस्ट. फ्यूचरिस्टिक मत करो, प्रेजेंट करो. आई एम द बेस्ट. एम आई एम द बेस्ट? अरे मुझे पता है आई एम द बेस्ट. आई एम आस्किंग यू गाइज. ओके, नाउ शेयर योर गोल्स विथ योर लव्ड वन. ये बहुत अच्छी चीज़ होती है. देखिए, आपको अगर एक्सप्रेस करना बहुत ज़रूरी होता है ज़िंदगी में. यू एक्सप्रेस, ओके, इन योर लाइफ यू हैव टू एक्सप्रेस गुड एंड बैड, राइट? आई एम टेलिंग यू, दिस 3 guys sitting there ना, my session is very entertainment for them. Big round of applause for these guys. So the thing is like that, कि in your life you have to be very expressive. If it is good, so अगर आप कोई goal decide करते, you are deciding some goal for yourself, you have to express with your family, you have to express with your true friends. Mark my words, true friends. Okay, consciously chosen true friends. So when you express this, automatically it will become your responsibility to complete those goals. अब इसका negative situation में हम सोचते हैं. You are feeling very depressed, you are feeling very low, okay? Suicidal thoughts coming in your mind, and you express those negative thoughts to your loved ones and to your true friends. What happens? You become empty. You tell your all negative thoughts to that person, that particular person loves you unconditionally, and your mind become empty. That thought for a certain period of time vanishes, and that window of time our brain uses to build a good thoughts. So in your life, आपकी ज़िंदगी में आपको एक्सप्रेस करना गुड और बैड बहुत ज़रूरी है. Student has to be expressive, right? Now, stay connected with your family and friends, right? Embrace your mistakes, celebrate your victory, give deadlines to yourself. और आगे क्या करना है हमें? इतना सब कुछ हम क्यों कर रहे हैं? We have to progress from excuse makers to action takers. अब इसमें at the end I know that कि this will be little drag, but बहुत सारे इंजीनियरिंग स्टूडेंट्स को मैंने देखा है कि वो सिगरेट स्मोक करते हैं. ट्रस्ट मी गाइज, सिगरेट स्मोक करना उसके जो पैकेट पे लिखा रहता है ना कि इट इज़ इंजूरियस टू हेल्थ, दैट्स एब्सोल्युटली फाइन. वो हम डेलिबरेटली नाइसली इग्नोर कर देते हैं, बट सिगरेट स्मोकिंग के दूसरे इफेक्ट जो होते हैं ना वो मैं बताती हूँ. अगर आप बुक पढ़ रहे हो, आप पढ़ाई कर रहे हो, और आपके दोस्तों ने बोला कि लेट्स गो एंड हैव, व्हाट वाज दैट वर्ड, क्या यूज़ करते हैं आप? सुट्टा. सुट्टा ना, राइट? ओके, सो चलो सुट्टा मार के आते हैं. सो टू रीच टू दैट पान टपरी यू आर गोइंग टू टेक 15 मिनट्स. वो आपका जो सुट्टा है वो फिनिश होगा अनदर 15 मिनट्स में, और उसके बाद जब आप आएंगे और पढ़ाई करने बैठेंगे, मार्क माई वर्ड्स, निकोटिन इज़ हैविंग सच अ इफेक्ट ऑन योर ब्रेन नर्व्स कि आपको अगेन पूरा कॉन्सेंट्रेट करने के लिए 20 मिनट्स लगेंगे. सो कितना मिनट वेस्ट हुआ आपका सुट्टे के साथ? 30 + 20 50 मिनट्स. अगर ऐसे ही अगर आपको ब्रेक लेना है तो यू टेक अ कॉफ़ी ब्रेक ड्यूरिंग स्टडीज़, और यू कैन गो फॉर अ नेचर वॉक, दैट इज़ फॉर 10 मिनट्स ओनली. और आप अगर नेचर में वॉक करने जाते हैं और अगर वापस आते हैं तो आपका कॉन्सेंट्रेशन लेवल हालांकि थोड़ा सा अप रहेगा एज कम्पेयर टू द प्रीवियस. सो बिग नो टू द निकोटीन. नाउ ये तो हो गया स्टडी के वाइज. जो सिगरेट पीते हैं ना, उनको आप कभी भी जिम जाते हुए नहीं देखेंगे या अपनी फिटनेस की तरफ काम करते हुए नहीं देखेंगे, बिकॉज उन बेचारियों के मसल्स में इतना ज़्यादा माइल्जिया निकोटीन की वजह से. माइल्जिया का मतलब होता है कंटिन्यूस मसल फटीग रहता है उनमें. उनका मसल डिपेंडेंट होता है निकोटीन के लिए. दे आर लाइक अ फुटबॉल. ओके, उनको लात मारनी पड़ती है हर बार एक्शन में लाने के लिए. वो लात होती है निकोटीन. सो दिस इज कॉल्ड एडिक्शन. डू यू रियली वांट टू बिकम दैट फुटबॉल who requires a kick? Is it serious? So, no, big no to the addictions, any addictions. So, am I right? हो गया पूरा complete? So, एक हमने अच्छा विद्यार्थी, उसका एक बहुत ही स्मार्ट सा गोल, और उस विद्यार्थी और उसके गोल के बीच में हमें जो भी आने वाला था वो भी हमने एड्रेस कर लिया. इज इट हेल्पफुल फॉर यू गाइज? मदद हुई कुछ? ओके. सो एट द एंड विल एक्सप्रेस द ग्रैटिट्यूड. ओके, यू कैन एक्सप्रेस द ग्रैटिट्यूड टू योर टीचर्स, ओके, जिनकी वजह से ये सेशन हो पाया. एंड आई एक्सप्रेस वट एवर विजडम, वट एवर ability I have to deliver this session because of my guru. So I'm going to express my gratitude to my guru, and you also please express your gratitude to your own gurus, and let's wind up this. Okay? Thank you so much. You all are brilliant. Brilliant. Thank you so much.
Thank you so much, ma'am, for sharing your wise words. We are grateful for having you here today. I would like to invite Annapurne Iyer, ma'am, to felicitate Ashwini Indulkar, ma'am. Thank you so much, ma'am. Let's move forward for our last technical session for this event by Shri H. Jairam sir, who is also chief guest for today's event. He is a task force leader in L&T construction. He worked for Chennai Metro Phase 2 projects for both underground and elevated. He has completed his graduation in civil engineering from Bengaluru and is an alumna of National University of Singapore and IIM Ahmedabad. He has total experience of 32 years and has expertise in TBM tunneling, conventional tunneling, marine works, and elevated metro projects. Today, he is presenting his work on geotechnical challenges in underground metro pertaining to Mumbai Metro Line 3, which he have even presented in the World Tunnel Congress, which is held in the Athens, Greece. Let's welcome him with a big round of applause.
Good afternoon. I am sure after the electrifying motivational speak, you are all fully charged. Is it so? Thank you. First of all, good afternoon to all the students here, Geotechnical Society members, professors, other post-graduation students and other dignitaries. It is my privilege to address you today. And my session is on geotechnical challenges in conventional tunneling under the sensitive structures. I'll be addressing the one of the. I have a pointer. Can I get a pointer? Can I get? Yeah. This presentation is about geotechnical challenges in one of the stations in Mumbai Metro Line 3, which one time I was heading as a project head. Go to the next slide. I think the introducer has introduced me. I am representing Larsen and Toubro. You must be knowing Larsen and Toubro is one of the largest construction conglomerate working in around 30 countries across the globe. We have pride in our engineering background, and we have pride as a nation builders. How many of you love your subjects? Am I audible to the last man? I can see only a few students lifting their hands. You cannot be Ranbir Kapoor, you cannot become, because you have already chosen to be here to complete your post-graduation or graduation. And you have no other way other than loving your subject and furthering a career, which I will talk about one or two sentences in the end after completion of this presentation. This is the Mumbai Metro Line 3. I think many of you. Hello. Many of you must be aware of it. From Cup Parade to Seeps, it's around 34-kilometer line consisting around 27 stations. It is totally underground. Around 17 TBMs worked at one point of time. This presentation is about Marolnaka station, which is quite unique compared to all other stations in this Mumbai Metro Line 3 project. Next. Okay, please. Okay, this Marolnaka station is situated on either side of the, in the Marolnaka junction itself, on the either side of the. Cut my flow. Okay, this is the Marolnaka junction, and this is the Maroshi Road, and you can see the this is where the Metro Line 1, elevated Metro Line 1 is passing here. These three are pillars. So the station is designed in such a way in two boxes, box A and box B. In between, the rock column is there just to safeguard the metro line, and also a lot of structures underneath. And in compared to the other station, this station box is only about 15-meter width. And other stations across, both in Pune and Mumbai, if you see, all are 20.5-meter width. This reduction is because of the lack of land availability, adjoining structures, and also the Mumbai Metro Line 1. Go to the next page. What we did, how we constructed, I will tell. This station is boxed on either side of the Metro Line 1. What we did is we constructed the tunnel first, and also simultaneously we constructed the station box. This is a parallel operation. Either side TBM tunnel first. The previous slide was at ground level. Don't slow. Okay. This is the longitudinal cross section of the Marolnaka station at platform level. You can see blocks A, station box A, and station box B. This is the TBM tunnel enlarged afterwards. This on either side you can see the TBM tunnel, and TBM tunnel is enlarged for a platform tunnel of 12-meter width, whereas the TBM tunnel is width of 5.8 meter and connected with the cross passages. Connected with cross passages for the movement of passengers and also for the utilities. This is Metro Line 1 pier. This rock pillar is around 50-meter width. Go to the next. Okay. This is the actual picture during the construction time. This is the 3D design BIM model taken from a BIM model. This is adjoining station, elevated metro Marolnaka station. So that is a brief background about the station. Now I will talk about the geotechnical parameters, how we have done the design, and what are the geotechnical challenges we faced. This is the geological profile, a typical geological profile. You can see from up to 6, again residual soil, 6 meter to 30 meter breccia, grade 4 and 3, based on the RMR values. More than 30 meter is breccia 2. Our tunnel is around 25 to 26 meter depth, breccia grade and 4, grade 3 and grade 4. Grade 4, highly fractured rock, we could see. Go to the next. As I told earlier, the station is constructed station is constructed by installing secant pile on either side of the box. See, this is 15.5 meter width box. Station it is bottom-up construction. First, we install this secant pile, and we go. As we excavate, we do with the strutting 1, 2, 3, even third level strut also there, depending on the depth of the secant pile. And afterwards, we went for open excavation with rock anchors. And these anchors, these are active anchors by pre-stressed wires itself. This is the temporary retaining wall system, temporary structure. Secant pile, and in rock, we did rock bolting and shotcreting. Once it is constructed, we started the construction by bottom-up method, by RCC construction. It's like as we constructed the bottom-up, we also parallelly started the construction of the cross passages, which connects to the main tunnel. Cross passages is done by pipe roof umbrella. I think many of the students may not understand this. I request you to go to some construction site and see. Pipe roof and umbrellas. Then we started going inside towards the TBM tunnel. Once the TBM tunnel is reached, then we started breaking the TBM tunnel. Then we started enlarging it by conventional methods, by heading and benching. And also this heading and benching is again the rock bolt based on the geological mapping. Rock bolts and shotcrete of around 200 through 2 layers of around 200 and rock bolts wherever is required. Once this, and also parallelly the station construction was done. So as I told earlier, in any of the engineering first is construction methodology is much more important, because how do we construct the station we have to design. First, before designing methodology, we have to freeze based on the geology, based on the land width, and also based on the machine available within the machineries available. So that is one of the reasons. Another way is also we could have gone for diaphragm wall construction, but it is not economical. You have to see the economical point of view. Go to the next page. These are the geological parameters. See, we did the tunnel design was done by using the station with the K0 value as 0.5 and 1.5. K0 value is initially we have taken, and we did the hydrofracture test in both the boxes, and the K0 value was taken as 1.5. Those post-graduation students can understand. And when we did the test, it was 1.7, 1.57. It was very close to 1.5. These are all the parameters, UCS values of the geological strata, hydraulic permeability, almost moderate permeability, unit weight, all these things. Go to the next. This is the FEM modeling. I think there are some design engineers must be here something. First is, see the phase, it is done it around 9 phases of modeling. One is relaxation of TBM tunnels by modulus reduction method. Then phase 2 is TBM tunnel excavation and station excavation at same time. So when TBM mining was going on, the station excavation also we started. Phase 3 is station excavation with the strut and whalers. Phase 3 again second, that will in certain whalers in stage 1, stage 2, stage 3. And also the anchor, as we went below the, near the termination of the secant pile, we installed passive active anchors. Then again third strut, afterward slope excavation in the rock by giving support by rock anchors and shotcrete. Then we did the rock. Then we did excavation. We did the cross passages. Then enlargement of TBM tunnel by conventional methods. These are the design stages which we have considered. Any questions are there? Later on, I am ready to take. Next. These are the consideration, FEM model consideration. Water table at ground level we have considered. Surcharge of 50 kPa. Plane strain model analysis by RS2 software. And model, we have kept it a fairly big model to understand the ground movement. When you keep the model very big, considering say around 70 to 100 meter width, you will be knowing how the ground is moving as you excavate up to a depth of 25 meters. Good. Next. As I explained, ground stability and ground movements were analyzed in various phases. See, these are the cross sections of TBM tunnel and enlarged tunnel. Metro line 1, 2, 3, piers, pier 1, pier 2. These tunnels are housed in between the two piers, which I will explain. So one of the major technical challenges for us is while construction of the TBM, metro line operation should not get disturbed. And the geology also is very weak. It was not a very strong geology. It's grade 3, grade 4 rock. Next. Geotechnical challenges is one is rock column. First is in the tender time, the rock column between the platform tunnel and the station box was only 2.7 meter. And when we saw the RS2 analysis, when we did the analysis, FEM analysis, this 2.7 meter rock column was not sufficient, it was yielding. So then we did many permutation and combination to house both the boxes in between the station piers so that both the station piers are stable and also our objective of construction of the station is achieved. So we have increased the column width to 5.7 meters. The platform tunnel even, it brought the platform tunnel to the very near to the pile foundation. Next. So this is the screenshot of the RS2 software FEM model analysis. You can see the red color which shows it is around 2.7 meter. It is yielding when we, because my laptop is controlling my presentation. Whatever. Okay. When we increased it to 5.7 meter, you can see the blue color. The log column was fairly stable. This is here the space between the tunnel and the station box is increased to 5.7. You can see the stable column. So go to the next station. Next station. This is where you can see one of the tunnel has brought, it is almost 6 meter away from the pile foundation of the metro line 1. Here it is around 12 meter. This is where, and also this is where it's by the dismantling the TBM tunnel, we were enlarging by drilling and blasting method. However, below this metro pier, we have not done drilling and blasting. We have done by conventional method only the excavation. Next. This is the typical cross section. This is 5 point. This is the convention. What you call platform tunnel, station box. These are the entry exits, entries, and this is the and this cross section is at cross passages where the movement of people or utilities are there. As I explained earlier, the cross passage was constructed from the station box and to enlarge this tunnel. Second, the first challenge was the rock column. Second challenge was when we were mining below the metro line 1 in the TBM tunnel, we encountered a water pressure of around 5 up to 4 kg centimeter square pressure. It's around 4 bar. Heavy ingress of water was there. So we took for 70 meter of tunneling, we took around more than 2 months. Even not even a 1 ring per day. Usually we go around 6 to 8 rings easily, but we were able to mine only 1 ring, 1 to 1.5 meter, 1 meter per day only because of the heavy ingress of water. My consultants came out with a theory of it is connected with the Powai Lake. It is around, it matches with the what you call altitude. Altitude. Go back. So what we did is we did a tomography, cross-hole tomography test. This test was done by the National Institute of Rock Mechanics. Go next. So this is we did these are 1, 2, 3, 5 boreholes. In this radar was passed based on the energy dissipation. The water path was found out. This is a soft patch. Water path was found out. In this M1 to M4, water was there. When we were mining here, we could find a lot of water. It was getting flooded. Go to next. So these are the pictures of the flooding during the TBM tunneling. Go back. So when this is done, what we did is we went for consolidation grouting. We call it as a permeation grouting, not a consolidation grouting, just to plug the seepages. It's called as permeation grouting. What we did is, as we excavated, we did probing. We found out any water is coming, and if any water is there, first we did the grouting in the soft patches. Then we did the probing. If the water is coming, then again grouting is further continued, so that the tunnel is this tunnel excavation phase is stable. Because above metro line 1 is also there, and also many structures are also there. This water is let out controlled way. It is not, the pressure is much more. So we used to open the gate a little bit only. If you open just for 1 centimeter, water used to flush out, used to guzzle out like anything. So what we did is, as a contingency plan for water ingress is, created a pipe-proof umbrella. Pipe-proof umbrella by SDRs, by self-drilling bars of 76 mm dia. We kept on creating the pipe-proof umbrella as we excavated. And also we did grouting wherever it is required based on the geology. And this pipe-proof umbrella during COVID time, March, April 2020, work was suspended for 2 months. And unfortunately, that time we were working below in this tough geological condition. Since we have taken proactive steps to stabilize the ground, so now, nothing has happened. In fact, there are no movement. Movement allowed, settlement is allowed only around 10 mm only. Go back. So this consolidation grouting is used by some what you call grouting agents we have taken the industry's help, Tampur 180 from North, Master Rock 160, Master Rock 55, and polyurethane. Why I am telling all these things? See, it is in this, all industry experts were involved. And, National Institute of Rock Mechanics was involved. Simper, Central Institute of Fuel Research and Mining Institute was involved for monitoring the blasting design and to keep the PPV value less than 2 mm. The industry experts chemical who manufactures the chemicals for grouting and water retaining what you call polyurethane resins. All the industry experts across the globe were involved to make it a stable phase and also to mine safely. And also we did, as we excavated, we also did the strengthening of the face by shotcrete. We did the tunnel advance from 1.5 meter was the phase earlier we thought. We started going in a smaller phase, 1 to even less than 1 meter also. We did additional phase shotcrete of 50 mm wherever the geology is very weak. And controlled blasting, as I told, we have not done below the Metro 1 control blasting. Control blasting was restricted up to 30 meter away from the pier. So this control blasting was designed and monitored by them. Their experts were there at the site continuously. And the vibrations were limited to 2 ppv, that is 2 mm per second. As I told, this is the grouting pattern. Even the pore polling pattern also almost similar to like this. We constructed a grout screens all along the tunnel face. This is the tunnel. We started drilling and created a grout screens. As we progress, this grout screens were also continued. Also a secondary support of pore polling was done. And the contract also was very stringent. The contract was allowing only 10 mm settlement and the tunnel convergence of only 10 mm only. So we did extensive instrumentation. And Geodata's Eopalinas software was used to monitor the settlement. See, the maximum vertical deformation was 10 mm only. Deformation of convergence in platform tunnel station and cross space is also monitored through optical targets. And also it was limited to at 10 meter interval. And even at closer interval also we did, though the design tells at 10 meter. The settlement and at surface and ground buildings, surrounding buildings were taken at 5 meter interval. And it was around the clock basis. So 24 hours, even during COVID time also we took special permission and our engineers were working and we were monitoring this. And this monitoring graphs were monitored through Geodata's Eopalinas software, which gives the trend also, which gives how the ground is behaving. This is the deep settlement marker above the tunnel crown. It is around 5 to 6 meter depth, where you will come to know if the in-between layers are also, if the settlement is happening, if the geology is stable, the settlements are happening in between in the rock face, then this deep settlement gauges will tell. These are the vibration sensor meter. This is a real-time monitoring system. It is implemented by some other company, Encardiorites. So this was online available. Anytime anybody can see. Round the clock at a fixed interval of 15 minutes to 30 minutes, we used to get the vibrations of this pier and also any strain on the pier if there is a strain because of any settlement. Stress cells and extensometers were there. So the instrumentation system across the station is so robust that even if there is a 1 mm, even 1 mm settlement or an 1 mm strain, in the peer, it is immediately alert that since it is a real-time monitoring, it will be the what you call the data will come on a real-time basis, immediate basis. So no need to go and check. It will come. It used to come in our text message through text messages. In the next, in the finally, what we could do is we could overcome all the geotechnical challenges like rock column, heavy ingress of water, and also the poor geology, and we could complete this platform tunnels below the metro line 1 without any settlement. You can see the fairly almost a flat graph. There is no almost settlements, even if it is there are 1 or 2 mm only, or lesser than that. So these are all the trigger values. Trigger values, we call it as many of the tunnel engineers must be knowing, AAA values, alert, action, and alarm. So when the when it alert level comes, we have to be alert. Action, then we have to be ready for action. Alarm means then we have to evacuate the people. So despite all the geotechnical challenges, platform tunnel was constructed by conventional tunnel method without hampering the metro operation. Heavy ingress of water and dismantling of TBM terminal was achieved as per the schedule. Despite the delay, stoppage of work for 3 months due to COVID, we could complete this project. And settlement and vibrations were in critical during the critical stage of excavation or within the permissible limit. This was possible by careful coordination. See, there are the big number of team is there, both on the contractor L&T side, the monitoring consultant side, industry experts from across the globe were there, designers were there, metro line, MMRC, governing body engineers were there. It was a concerted and a consistent effort. We could complete because of this consistent and disciplined efforts. We could complete this project on time without any settlements and without any injuries to the people. My presentation is over. I am ready to take any questions. Any questions? After such a motivational speech by the lady, you all should be energized. And I was asking, first thing is, how many of you really love your subject? I could see only 2 or 3 hands going up. See, the industry needs good civil engineers now, good geotechnical engineers. We see really a dearth of people. Actually. Mostly, you may be thinking that the software and other industries are looks attractive, but equally the civil engineers today, geotechnical engineers are equally well paid. Industry plays well. There's a good system of working is there. It is not that it was earlier when we started career around 30 years back. It was not so. So now the industry takes care. There is a good HR system is there in across the company, all companies, and industry needs people. And those of you think that I think that lady was telling your subject should be relevant. What you do and what you learn should be relevant. And I can give an example. When I thought of a career change in 95, 96, one of my colleague, he joined Mahindra Tech. I also got selected, but I didn't join because I thought what I will do in software, it is not my field. But he's there in UK, but he never attained seniority. That's because maybe he might. Initially, I also thought he is earning more. It's not so. Initially, it looks lucrative outside world, but when your core competency is somewhere else, you will not be able to achieve the accolades in the long run. And so that is the message which I want to send it to the young students here. The field, though civil engineering is very dynamic, and also it needs little bit of efforts. You need to go to the field. You have to go to understand, to become an expert in the field. A lot of hard work is required. It is required in any field. Even if you're a doctor also, if you are a doctor also, you have to work 24 hours. So the field is very good. And the industry recognizes also the engineers. There is a dearth of engineers in this thing. The emoluments are very good also. Also, the AI artificial intelligence cannot replace you so easily. Other day, last week, I was telling Mr. Kulkarni, my good friend and my respectable friend also. See, the AI in the Harvard University, one of the seminar I was attending online, it tells, okay, all this repetitive work what we do today, it will all be replaced by AI. Like analytical skills, any analysis, data, many of the people after doing, many of the students, they go after doing civil engineering, they go to the software field. But what they do is data entry or data logging or data analysis, that will all get replaced by AI, artificial intelligence. But not the construction of big buildings, construction of underground structures, which will, where in the next 2050, around 70% of Indian population will be in cities, where underground construction, tunneling, city below the underground also. Like now, if you see the Bar Construction, one of the leading construction firm, they know they can construct today. They will make a tunnel below here, below the tunnel, below this building, and they can construct another building, say 50 meter below, without disturbing this. That technology, they were giving the presentation to me in around couple of months back. So technology is also is going, but the civil engineers, it cannot be replaced so easily. Though in analytical field, design field, and yes, it may be, but not in real construction. We are understanding the ground. To understand the ground and take action, good geotechnical engineers are there. So having done civil engineering course in one of the best university like MIT, I request you to put all your efforts to enrich yourself in the subject. The industry is very wide, and since we are in a developing stage, India is a developing country. Maybe another 2045, 2050, the government tells 2045 we may become a developed nation. It may go another 25 to 30 years. This country will grow both especially in urban areas and also in underground spaces, geotechnical spaces. Please love your subject, put all your best efforts. I would like to see many of you maybe in the coming years as a good geotechnical or civil engineering experts. Thank you. These are some pictures that have not come after construction. You can see the cross passages. This is the reinforcement tile after completion of the tile. These are some references. This presentation is available. You can refer later on. It's a curious cat. Thank you. See, we used very optical targets. We used the Encardio rides have their own vibration monitoring instruments are there, which also gives the strain gauges, which is online, which is fitted with the chips, which will give you the vibration on continuous basis. And for PPE measuring instruments we use. See, there are the two types of instrumentation. One is manual-based monitoring we did. And on Metroline Pier, we went for online monitoring. So these are all the instruments, modern instruments like strain gauges and vibration monitoring. If the settlement is happening, it will give vibration. So it will come on your computer screen. Even if it goes beyond the permissible value, alert will come. So that was taken care by those methods. Yeah, real time. It's real time. In all sensitive structures, we did a real time. Any questions? Any more questions? This all together, This station itself is around 1.2 to 1.3 CR. That including what you call monitoring for 24 months. Thank you. Good. See, it's a good question. See, as I told, the 70% percent of the country's population will reside in cities. City needs infrastructure. If you come to this now today from airport to here, I took around nearly 1 hour. So, in fact, I did a small project around 16 years back. I think 16, 17 years back. That time also it was very congested. Now, with this thing, underground tunnel, especially for road tunnels, underground tunnel for irrigation, underground tunnel for watering, for what you call water transport, especially the sewage systems in major cities. And like in Bangalore, now we're thinking of going for some 50,000 crore worth tunnels if there is a flooding. Like so in a V shape, in what you call star shape, the tunnels will go. Each and every tunnel cities will have tunnel for metros, tunnel for high speed. High speed now everywhere it is construction. Especially the government of India has announced around 6,000 kilometer of high speed rail. But in high speed in urban area you cannot construct it elevated. It has to be underground. And now in across Himalayas itself around 200 kilometer of tunneling is planned. So underground cities are going to come up. As I was telling, underground cities, there is urban space will be much more constrained. So there will be a lot of opportunity. Thousands of millions of what you call job opportunities will be there for, especially for those tunnel engineers, geotechnical engineers. So geotechnical engineering is now today we don't get that engineers. To be very frank with you, we interview many candidates. We don't see the fire, not even the knowledge. Fire is there only when you want to do something. Then fire in the belly will be there. Our knowledge is there when you listen to your the teachers, indulge interact with your teachers and professors. Then knowledge will come. Please, my advice is to put all your efforts to gain knowledge. So opportunities are unlimited. And now in the project in which I am working today, around 8 in the Chennai Metro itself, around 21 TBMs are working. And out of that, around 8 by L&T itself. And we are getting the geotechnical engineers and tunnel experts from abroad. They are, some are Europeans, some are from other countries, Russians, all these people, because there is a depth of knowledge. Please understand, if you are good in subject, there is no end for your career. Your career will be very, very bright. Thank you. Any more questions? Youngsters should ask questions. Please develop what you call curiosity and a habit of asking questions. I was also like you earlier, but later on I started realizing, then we started asking, because if you make habit now, then it will get, you will learn something. Huh? Yes. Okay, thank you. Thanks for the opportunity. Thank you.
Thank you so much, sir, for sharing your amazing experience with us. Now, as we are starting our valedictory function very shortly, I request everyone present here to be seated here only. We are just arranging the dais. As it's done, we'll start it immediately. I request all the volunteers and the participants of the competitions to be present here. Pune chapter, Shri Vikas Patil sir, and our mentor of IGS Pune chapter, Shri Ramesh Kulkarni sir, and Deepali Kulkarni ma'am. We'll start the felicitation of the guests.
Let us all with respect take time to felicitate the dignitaries who are present here today who made this event a success. I would like to request Dr. Anil Joseph sir to felicitate our chief guest, Sri Jairam Haluvalli, Task Force Leader in L&T Construction. Let's welcome him with a round of applause. Thank you very much, sir. I would further like to call upon Sri Jayaram Halwalli for felicitate Dr. Sandeep Potni, sir, Head of Tunnel Engineering Department, MIT World Peace University. Thank you so much, sir. Let's welcome Srimati Deepali Kulkarni ma'am, who is the coordinator of this event.
On the behalf of our World Peace University, I will just take 1 minute of yours. I'm sorry for interrupting in the program. We would like to show our gratitude by felicitating Ramesh Kulkarni sir and Vikas Patil sir for allowing us to host this particular event in our campus. So it was a great privilege to have all of you here, along with the dignitaries and the esteemed stalwart expertise who came all the way from the various parts of the country to the campus. So to express our gratitude from the World Peace University, we would like to felicitate both of them, because for the last 2 days, they are doing the felicitations with the mementos of the IGS protocol, which we did not feel to intervene, but just 2 minutes. Please excuse me for that.
Let's welcome Srimati Deepali Kulkarni ma'am, who is the co-coordinator of this event. I would request Dr. Anil Joseph sir to please felicitate the ma'am. Let's welcome Deepali ma'am with big round of applause. Thank you very much, sir. I would like to invite Sri Vikas Patil sir to take over and address this crowd.
Good evening, friends. It's really surprising. I thought that the program is all planned, and I'm really very happy to even just say a few words about this event as such. First of all, this is the 75th year of celebration of Indian Geographic Society. As I said, this is a proud national level organization, and we always have in the heart, yes, we are a member of this national organization, proud member of organization, and not only national organization, but which is directly connected to International Society for Soil Mechanics and Geotechnical. So ISMG is very much in connect. Our president is flying, very soon to USA, to Russia, and all the while he said that he's flying everywhere nowadays. And friends, in the mark of celebration, first of all, they choose Pune as a center to have this celebration and organize the event and just celebrate it. But I'll say that in our this entire celebration, when we say celebration, it is something, when we celebrate something at family, we understand, we enjoy that. So in our enjoyment, in our celebration, MIT has really come up with such a great support, unconditional support, strong backup. Madam, Bukil Madam, we are really, from the bottom of heart, I express my gratitude towards my alma mater, that without the support of MIT organized everything, sir. See, as you say, we don't require money. We have all strong people with us. Your blessings are there. Chairman, President, sir, your blessings are there. AP Singh, sir, your blessings are there. But my people are so strong. See, this is unconditional, without anything. Perhaps see backup in such a way. Now you say, whatever you want, we are there. But program should happen, 2 days program, no curtailment, nothing. We have to make it really mega event. And with their support, we organize this. So this is my really gratitude towards my alma mater. And this MIT is also recognized, is known for the birthplace of Indian Geotechnical Society Pune chapter. Pune chapter was established by our Bhishma Pitama, Ramesh Kulkarni sir, who is sitting here. I call him always Bhishma Pitama. This session, last 2 days, I think I missed that, but no, today I will say, why I say Bhishma Pitama, he is the person who is witnessing. Friends, in 2003, when it was established, that time we were very small kids, maybe in the, say, primary or something like that. So that time, he established Indian Geotechnical Society Pune chapter here in MIT campuses. So 1st May 2003 is the date of establishment in campus, and that is we recognize as a establishment of IGS Pune chapter. So to the birthplace of IGS Pune chapter. So this is really great coincidence that the place where the IGS Pune chapter took the birth, there only we are celebrating over 75 years. And I see that with the with the lead of MIT and the way they are marching towards, because this earlier it was MIT, now it is MIT World Peace University. Tomorrow we can say that MIT with the global university over here, we'll see that n number of candidates from outside India, and they will come to learn over here, and they will just seek the admission by just enrolling over here, and that with our dream that our 100th of year will celebrate same over here in campus. That will be my dream, that MIT will be the institute which will take lead for that. So that is one thing. Secondly, I'll say that all student chapters of IGS Pune, sir, madam, almost we stop my people. Such a great support from my IGS staff coordinators, that everybody, they said that yes, we are sending people, we are coming for the celebration. So celebration they enjoyed last 2 days. All 6 sessions which were there were technical sessions, friends. It is not expected that you should become a master and technocrat in 1 or 2 days, but it is very much there that you should come to know that something new is there, and some words like say Jairam sir said, who is the great ambassador for not only civil engineering, not only for geotechnical engineers, but for civil engineers also. He just gave you the idea what scope is there in coming days, and as such, just it was the idea that you people should come to know that what is the future for you if you just march in the path of say geotech engineering assets. So all students, those who have come here all the while, madam, we have organized for the first time, say some more than 30 students, they have come from outside Pune, and their accommodation also we organized, and even students also, the boys also came from outside, they stayed here and they are attending this session. So I'm really glad and I'm really grateful to all my student chapters for just attending this session. And the most important is that Deepali Kulkarni madam. She is the co-coordinator for the event, but she really took a lot of efforts in organizing single-handedly. Yes, our support is always there. My all EC members are so strong and powerful that this time, Deepali Kulkarni madam, she just show her capabilities, and this entire event of Mahafest, she took the initiative. It is not easy, friends, to just have this session. Once you take the responsibility, then you will understand. Her daughter is, she's having high fever still. She said, I'm just coming little late, but she's coming. So everything is not all well everywhere, but still people are managing. The plan is there, people are having some goal is there, and to just march on that goal, march on the responsibilities, they are putting all their efforts. So Deepali madam, I really strongly acknowledge your great efforts in organizing this event. Thank you, sir. I think our president is having a flight now, so he may be taking leave. Sir, thank you for attending this session. Your blessings, AP Singh sir, your blessings, your support is really our backbone, and we'll continue this, and we are always there with you. Thank you, friends. Thank you, one and all. Thank you.
Thank you very much, sir, for your wise words. For these 2-day events, we have conducted 3 competitions for students. We have felicitated our respected judges. I would like to call upon Sri Jairam sir to felicitate the Dr. Manish Dikshit, who is the secretary of IGS Chhatrapati Sambhajinagar chapter. Let's welcome Dr. Manish Dikshit with big round of applause. Thank you so much, sir. I would again request to Jairam sir to felicitate Dr. Krishnaya sir, who is the vice chairman of IGS Pune chapter. Let's big round of applause for Krishnaya sir. Thank you so much, sir. I would like to call upon Dr. AP Singh sir to felicitate Dr. Sachin Jain, who is the executive committee member of IGS Pune chapter. Let's welcome Sachin sir with big round of applause. Thank you so much, sir. I would again request to Dr. AP Singh sir to felicitate Dr. Uttam Kalwane, who is the chairman of IGS Chhatrapati Sambhajinagar chapter. Thank you very much, sir. I would like to call upon Sri Ramesh Kulkarni, sir, to felicitate Sri Yogesh Shermale, sir, who is the Executive Committee IGS Chhatrapati Sambhajinagar chapter. Let's big round of applause for Yogesh, sir.
Good evening, all. Sorry for interrupting. I got to catch the flight, so if I don't leave, it won't happen. But then I would just like to tell that I have told a lot, so I think there will be a difference in your attitude, and we have seen that to work there is a difference. With work with passion, we have seen 6 people talking here, communicating. Here, we have to make it happen. And beauty of that is that civil, it's the mother of all engineering. Foundation is always buried below. And unless and until there is a problem, we don't know what is happening. And we always try to bury our problem and don't discuss that. So that is the importance of meetings or conferences in geotechnical engineering. Because in textbook, everything is perfect. But in field, everything varies. So that variation to be captured, discussed, and deliberated, that is where the knowledge improves, and documented, like it was documented, very professionally explained by Jairam sir how it was done, including the sensors on the pier which gives every 5 minutes warning what exactly is happening on that. So that is the technology which has come to the world, and you have to bring that technology to India in geotechnical engineering, and another 30, 40 years, your career is safe because India has to learn lot in civil engineering. Wish you once again all the very best, and I would like to thank MIT University College for this excellent program conducted, and I know it's our B.Gdeshmukh and the team here, and whenever I need a support, I call upon IGS Pune chapter because they are the best chapter in the country, and more importantly, they want to be the best. That is the most important thing. It's not that one semester you do good, but you want to do it continuously. And moment I take the charge of president, I got a call from Annapurni here from Pune asking that what all I should do so that next year, December, when you are planning the award, I should get the award for IGS Pune. So that's the planning. So last message, if you fail to plan, you are planning to fail. So plan well. You have to spend your 60% time for planning and 40% time for execution. And that is the Japanese technology. Sorry, the flight won't wait for me. I would have loved to talk, and there is a big problem. Once I get a mic, no, I don't feel like leaving that. So, but I would wish you all the very best, and see, we are seeing some of the best and brightest engineers in the future here. And like the story I told, one day I would like to see the big, largest and the most beautiful thing in India, and has to be created by you people. And Jai Hind, and let us be all proud of civil engineering. Thank you.
Thank you very much, sir, for guiding us. I'd like to ask Sri Ramesh Kulkarni, sir, to felicitate Srimati Manisha Sawant, ma'am. Let's big round of applause for Manisha Sawant, ma'am. Manisha Sawant, ma'am, is a jury member for Pick and Speak event. Thank you, sir. I would like to call upon Sri Ramesh Kulkarni, sir, to felicitate our respected organizing team member, Dr. Shubhangi Shekokar, madam, for coordination to conduct this event. Let's big round of applause for Shubhangi, ma'am. Thank you very much, sir. Now, let's felicitate our sponsor who made this event a success. Let's thank the IGS headquarters, IGS Mumbai chapter, and S&R Geotechnics Mumbai. Let's welcome Sri Ramesh Kulkarni, sir, to felicitate IGS Sambhaji Nagar as I call upon Uttam Kalwane, sir, Manish Dikshit, sir, and you to give it. IGS Sambhaji Nagar chapter is one of our sponsor. Thank you very much to all. I would like to hand over the mic to Tanvi Patil for further event.
Thank you, Prajwal. We'll move towards the prize distribution ceremony of the various competitions. Let's have a round of applause, guys. I will now call upon our chief guest, Sri H. Jairam sir, to hand over the prize for the winner of a poster competition. So, from the undergraduate sections, third prize goes to Sarang Patil, Sartak Zambre, Sanskruti Shinde, and Alisha Hotkar from RIT Islampur. I think they are not here. We'll move towards the second prize. Second prize goes to Priyanka Ingore and Rajeshwari from MIT Aurangabad. First prize goes to Maheshwar Pawar, Kamlesh Patil and Milind Patil from PCCOE. जेवण झालंय ना सर्वांचं? टाळ्या. From postgraduate sections, the first prize goes to Ranjit Khamkar, Ayush Badane, Sangram Kilore, and Ashutosh Jagtap from MIT World Peace University. Thank you, sir, and congratulations to the winners. I will now call upon Dr. Shantini Bokil ma'am, HOD MIT World Peace University, to hand over the prize for the quiz competition. From undergraduate section, the third prize goes to Ankit Kumar Singh and Chandrakant Dalvi from JSPM Nare. The second prize goes to Om Gayakwad and Aryan Taware from MIT World Peace University. I think they are not here. Sorry, Sapsi. From D.Y. Patil Akurdi and Vyavhar Rishikesh from PCCOE. Third prize goes to Aditya Dharyaya and Pradnya Bante from SPPU. from MIT World Peace University. Aviraj Kale and Ruturaj Sonavne from MIT. From MIT World Peace University. Thank you, ma'am, and congratulations to all winners. I will now call upon our conveyor, I will now call upon Sri Vikas Patil sir to hand over the prize for the winners of Peak and Speak competition. From undergraduate section, it's a tie. The second prize goes to Bhavesh Rane and Pradnya Agle from VIIT and PCCOE respectively. The first prize goes to Jay Shivatkar from DY Patil Akurdi. Is there anyone from DY Patil Akurdi? From postgraduate section, the first prize goes to Shandiala from SPPU. Someone from SPPU can. Thank you, sir, and congratulations to all the winners. The next session will be taken by Prajwal.
Thank you, Tanvi. Now we will start the felicitation of the people who work hard to make this event a success. I would request all the dignitaries to felicitate the student chapters who volunteered this event. Let's call upon the stage the MIT team along with their faculty coordinator, Dr. G.S. Ingle sir and Dr. Shubhangi Shekukar ma'am, who represented a host of this event for 2 days. Let's big round of applause for MIT team. I would request all the MIT volunteers, please come on the stage. Thank you very much. Let's call upon the stage the COEP team along with their faculty coordinator, Dr. S.M. Naugare sir. Big round of applause for team COEP.
Let the hands keep doing the job. Keep clapping, please. Please continue. So there is one more announcement as the team is here, CUAP. So we have an award for the best student chapter participation. That also goes to College of Engineering, Pune. Big round of applause. Request Jairam sir to please hand over the trophy. Please clap, friends.
Thank you very much, dignitaries. Let's call upon the stage the PCCOA team along with their faculty coordinator, Sri S.B. Bane sir. Sri Shailendra Bande sir. Big round of applause for PCCOA team. Thank you very much. Let's call upon the stage AISSMS team along with their faculty coordinator, Dr. R. Nellaude sir. Big round of applause for AISSMS team. नहीं मैम नहीं मैम स्टूडेंट अब तक दूसरे Thank you very much, dignitaries. Let's call upon the stage PVPIT team along with their faculty coordinator, Dr. R. Sorate sir. Sorte sir, sorry.
Instead of Sorte sir, Aditya, you can come up on the stage. Yeah.
Let big round of applause for PVPIT team. Thank you very much, dignitaries. Let's call upon the stage RSUAE team along with their faculty coordinator, Manisha Sawant ma'am. Let's big round of applause for RSUAE team. Thank you very much, dignitaries. I would like to hand over the stage to Harsh.
It's a good exercise for the dignitaries. Standing up, sitting. Stand up, sit. So we have one special prize. So this is so as we have a lot of student chapters who have come out of Pune. So we have an appreciation award for outstation student chapter for their active participation in this event. And the award goes to RIT Islampur. Request the team RIT Islampur to come forward and collect the trophy. RIT Islampur.
Thank you, everyone. Now let's move forward with the felicitation of all the participants without whom this event wouldn't have been the event that we are enjoying today. So I would now request Vikas Patil sir to hand over the prize for the colleges that I would be naming. I request one faculty coordinator and one student from that college to come on the stage and collect the certificates on behalf of entire college. I call on A.G. Patil Institute, Solapur. Do we have them in the AISSMS Pune? Arvind Gawli College, Satara. COEP Technological University, Pune. Dhole Patil, Pune. Datta Meghe College of Engineering. Dhole Patil. Next we have D.Y. Patil, Pimpri. Next we have JSPM NTC. D.Y. Patil, Pimpri. Can we have a big round of applause for them? Next we have KIT College of Engineering, Kolhapur. JSPM NTC. Do we have MIT ADT? Next we have MIT Sambhajinagar. Next we have MIT WPU. Next is NMIMS. After that, we have PCCOE-R. Do we have anyone from PCCOE-R? Next, we have Rajaram Bapu, Islampur. Next we have Sardar Patel College of Engineering, Mumbai. Next we have SPPU. Let's have Sinhagad Vadgaon and Sinhagad College, Pune along together. Do we have any representatives from Sinhagad College? Next is TSS MS BS ROER Nare. After that, we have TSS MS PVPIT Bowden. Following them, we have VIIT. Do we have anyone from VIIT? Next is VPK BIT Baramati. I'm not able to hear the claps, please. Next we have MIT AOE. Do we have anyone from MIT AOE? Anyone from AP COE? Huh? Yeah, AP COE. Yes. Go ahead. Do we have PCCOE in the room? Anyone from PC? Thank you everyone for being the part of this. Thank you so much Vikas Patel sir for holding on. Now we are coming to the end of this 2-day event, which has become a success because of all your presence. I will now invite Professor G.S. Ingre to deliver the vote of thanks on behalf of MIT World Peace University.
Thank you.
Good evening, ladies and gentlemen, dear students. On behalf of MIT World Peace University, Department of Civil Engineering, and the IGS Maharashtra, which includes Pune, Mumbai, Chhatrapati Sambhajinagar, Amravati, Nagpur chapters, it is my privilege and pleasure to propose a heartfelt vote of thanks for the enlightening, informative Mahafest on tunneling and underground structures. We have had an opportunity to gather here and explore into the fascinating world of underground engineering and construction, thanks to the contribution of many individuals and organizations. First and foremost, I extend my sincere gratitude to our distinguished chief guest, Engineer H. Jairam sir, whose presence added immense value to this event. Your insight, wisdoms, and expertise have enriched our discussion and inspired us to reach our heights in the world of technology. We are honored to have sir here. I would like to express my profound appreciation to our speakers who have generously shared their knowledge and expertise over these 2 days. Your presentation were not just informative but truly inspiring, opening our minds in the incredible innovation and challenges within the field of tunneling and underground structures. We are deeply grateful for all these expertise. I express my gratitude towards Dr. Anil Joseph, President of IGS New Delhi, Dr. A.P. Singh, Secretary IGS New Delhi, Dr. N.K. Samadia sir, past President of New Delhi, for their motivation and support. I also thank to Professor Dr. Nilima Satyam, NEC member, IGS New Delhi, and convener, Professor Dr. Dasaka Murthy, Chairman of IGS Mumbai. I also thank to the co-conveners of the event, Engineer Vikas Patil sir, Chairman of IGS Pune chapter, Dr. Manish Dixit, Secretary of IGS Chhatrapati Sambhajinagar, Dr. Anant Dhatrak sir, Chairman of Amravati IGS chapter, Dr. Prasant Dehle, Chairman of IGS chapter Nagpur. Also, our IGS Pune chapter backbone, or we are seeing the mentor, Engineer Ramesh Kulkarni sir, for his continued support and motivation. I express my gratitude towards our Dean of Faculty of Engineering, Dr. Dinesh Seth sir, and our Head of Department, Civil Engineering, MIT World Peace University, Dr. Shantini Bokil madam, and my all senior staffs and other colleagues for their valuable support and motivation. I would also like to thank the IGS student chapter coordinators from the various institutes, student coordinators, and especially volunteers from MIT World Peace University, SSPMS, COEP, PCCO, and all other institutes. Your efforts have played a significant role in the success of this technical event. Our thanks are also going to the organizing committee and volunteers who are worked tirelessly behind the scenes to ensure the smooth execution of the event. Last but not, I would like to thank all of you, your esteemed audience, participants. Your presence here today reflects your commitment to the advancing in the field of tunneling and underground structures. Your passion for learning and innovation is what makes events like this meaningful. In conclusion, as we have lived here today with deeper understanding of tunneling and underground structure, let us carry forward the knowledge and inspiration gained from this Mahafest into our respective areas or field and continue to push the boundaries of what is possible in the underground. Thank you all once again for your unwavering support and participation in these technical sessions. We look forward to meeting you again in future events, and until then, safe journey, and may you all continue to explore the depths your chosen path with enthusiasm and dedication. Thank you all.
So I announce that the program is concluded now. Thank you all the dignitaries, all the participants, all